throughout its history. Currently, a rapid progress in the field is being witnessed, which is known as AI boom. Therefore, in this mega event, today's sessions, AI universe is being unveiled before you. In this regard, we are commencing today's sessions with a panel discussion from the experts in the field. The topic of the panel discussion is Foundation Models for India. As a moderator of this panel discussion, may I request Srimati Kalika Bali, Senior Principal Researcher, Microsoft Research, to kindly come on to the dais to moderate today's panel discussion. Welcome, ma'am. And as panelists in the discussion, we have Mr. BIEC, co-founder, Server AI with us. Sir, a hearty welcome to you, sir. I also welcome Professor Shashikumar Ganeshan, founder, Senator, Professor IISc, for today's panel discussion. Ladies and gentlemen, please welcome Mr. Anand Nagaraj, co-founder and CEO of Gemini AI, for today's discussion. On behalf of all the organizers, I want to extend a warm welcome to all the panelists. Now the stage is to Madam Kalika.
Welcome everyone and welcome to the panelists. I have been so excited about this panel because what we have here are literally people who are pioneering India's effort in building foundation models. So I'm sure this is going to be a very exciting and interesting talk of where we are, what needs to be done, what are we doing well, and where do we need more support in various ways. So, to the entire panel, my first question is, there's a lot of, this is a little bit of a polarizing thing across the world, whether we need sovereign models or we don't need sovereign models, do we need India-specific models or we don't need, is it enough to take open-weight models and fine-tune them or tune them in certain ways? So, I would like to ask all of you what your view is on why we need to even go down the line of building our own foundation models in the country.
Should I start? Yes. Hi. First of all, very nice to be here at BTS. And I think, what we've seen is really, in the last 3 years, these foundation models have made, incredible progress, starting from GPT to whatever it is today. I suppose it was Gemini 3 was announced yesterday. I think the capabilities of these models are growing dramatically, and also the kind of investment behind these models is dramatic. So therefore, somebody will say, why don't you just use the global models and things like that? And there is a certain case for that in certain kinds of scenarios. That's something that's possible. But I think if we don't put an effort in foundation models, I think we'll become a digital model. Literally, that's really what. So that's why we need to have foundation models. And what is really, I think there are obviously, if you look at models, there are two kinds of models, right? There are the closed models where you just have an API endpoint and you're calling the models. And then there are the open models, right? The open models are where the weights are available and you host it yourself and you actually use those things. Now, the point even with an open model is really one of the things that's there is, and I think there was some recent research coming out of Anthropic, which actually said that even with a very small, if I actually had an open model which was made, where you can actually poison the model with a very small amount of data, and you can't understand what the impacts of that would be. And that's something which is very interesting, because today, I think we started off with the llamas of the world and being the premier open source models. But today, if you look at most of the top open source models, they're actually from China. I mean, that's the fact that if you look at the best performing open source models today. And so therefore, that's, of course, there are certain kinds of use cases where I think that fine-tuning an open model we actually have risks that we don't understand. But still, I want to say two more things. That the other reason why we want to have a foundational model is that when you look at the data that is used to train a model, right? I think that, for example, we don't know the exact numbers, but certain kinds of early open models we know. Maybe the data which was of Indian context supplied was sub 1%, right? That was the data that was, so how do you expect a model where really sub 1% of the data trained was actually of Indian origin? Now we are obviously, the AI Vision has actually given us a charter to build a foundational model. And we are talking about, for example, we have, we're going to be launching this model in the next couple of months, and it's a 120 billion parameter model with more than 17 trillion tokens, and out of which maybe 15%, 20% are Indian tokens. So that's the other part. The third thing I think is that this technology is so important, and it's so I would say that if you don't know how the core of this technology works, that is starting from scratch, how you actually train a model, I think that it is something that if you don't know how to do that, you'll never know how to do that. And I think that from a strategic reason, that's something.
So let me take this question more of the philosophical side. So of course, this question is not only for this technology. I've been answering such type of questions even when we have the International Supercomputer Mission. Do we really need a National Supercomputer Mission? In fact, unfortunately, I would say that we were not so successful in supercomputing. Otherwise, we would have been the leaders for AI. Because that technology put us behind, and that is the reason we are behind in AI technology. Similar to that one, if we do not build our foundation model, as we already rightly pointed out, we will not be learning how to do what to do, right? Know-how technology is very important. If we are not mastering the know-how technology of the AI today, we will be missing out the future technologies as well. We will be behind the future technologies as well. So from that perspective, irrespective of, because this question has been asked at many forums and answered by many different questions, but to me, right, if we do not know-how technology, do not know how to build the foundation models, then definitely the next technology, like the AI technology, will be behind us. So from that perspective, we need the talent to build, we need the talent to know how to build the foundation models, and we can definitely innovate. Innovation is the key for any new technologies in the future. The startups, Semicons, we talk about our different metrics, but in order to innovate, we really need to learn the technology. To learn the technology, there is no best way other than by doing it. So from that perspective, more than what's the impact that the AI model is going to create, I'm talking about like in future, but I want to have the technology, then we should be knowing this technology. That's my submission.
I think thanks for having me here. Both my co-panelists covered the need of it, but I think the fundamental part as a country that we are in, AI is a necessity for the next 800 or say 800 million people. We are all in Bangalore. We understand what is happening in the global world. But the need of AI to people who are less privileged than us, that is something that we need to build. And it acts not like an adoption, but it acts like a necessity for people. Like for example, I come from a village which is around 200 kilometers from here. I still today, internet is still used for WhatsApp, YouTube videos, and some news. But there are 100 different things that can empower people there. And unless we control the whole tech stack, whatever Vivek said on data, he said on knowing how, unless you have all of this and with an intent to solve for the class that will benefit a huge out of AI, right? I mean, we all have definitely adding efficiency in our conflicts. But there is a tectonic uplift that happens to people who are deprived today of various things. I mean, again, in my village, when I go by, there are so many government schemes that are there, but they don't know how to use it. It could be lack of information. It is the way they access that information. I think where foundation models that are the need for it, is to empower such people. And I think for that, we need to build a foundation model that is truly Indian. The second part of it is the cyber security and the defense security. And we are growing, we are fourth, fifth largest nation. And unless we need to protect our assets, unless we control a model in and out, we are prone to all sorts of attacks coming from different parts of the country, from the world. So I think these are the two biggest needs for AI for a country like us. One on our aspiration to grow bigger and bigger, and other is how do I uplift the rest of the citizens to the next stage where the world is progressing.
Thank you, Anand. Actually, I will, ask you the next question. Since you have been doing this, you've been creating speech models long before generative AI was a thing, right? Like just in the start when LLMs were becoming the mainstream technology or model to go to. So, can you talk a little bit like on how the technical part of like moving from, the machine learning LLM kind of phase to now with generative AI, how things have like changed technologically and how technically, scaling, because you mentioned about scale, how technically scaling is either more easy, difficult, and where do you see the challenges in that?
See, when we started building, we were building on classic ML models, deep learning models. Today, it is all different types of hybrid transformer architectures that you use, and also data sets that you are trying to get a good speech system process. I think this is way back in 2016. It was about 10,000 hours of audio. You could get good speech system, and you would probably hit about less than 8-9% word error rate. But again, all of this were done on singular language. A country like India, even then and today, you need a multilingual, you need a code switch language. Someone, probably most of us here would talk in 2 or 3 languages and we keep code switching. And you need a much real-time efficient system. So challenges, with the whole, I would say, even without calling it as LLM, with the whole transformer architecture and attention to the transformer, there was a significant progress done on speech. And that fused with your LLM layer makes the understanding more simpler. But again, you hit challenges of scale. Today we do, at any given point of time, we largely work in audio voice AI space. On a good day, we handle close to 10 crore voice calls per day. So that means about 1 lakh audio calls hitting my systems every second. I need to give a response time less than 150 milliseconds at the audio layer. And this could be multilingual, it could have huge background noise coming in. People would put their phone on speaker and would be talking from far. You need to handle what do you call as far field in audio, things like that, right? I think the complexity of model got complexer, and your model got intelligent in terms of handling. So we took I would say, approach where earlier we had a separate denoiser block, separate far field block, etc. But now again, we are making the networks intelligent that all of them are fused. And we also look at this at the training level itself. So that your training data is also very similar to your field data. Classical thing, I remember one experiment which I think IIT Madras tried. They built a good model, went out, put it to public for farmers, and first word did not fail on telephony network. So you are very good at a 48 kilohertz or a 16 kilohertz when you are talking to your laptop, but when you go to a telephone line compressed at 3G or 2G or even 4G networks at 8 kilohertz, sub 4 kilohertz data coming in with huge background noise of a car or someone singing behind. So these challenges have become, with the neural nets, these are much easier to solve, but these are challenges that you need to solve to handle the AI systems that can actually make a human-like conversation with a user.
Yeah, that's very true. Actually, I remember ages ago, even before 2016, there was this initiative by one of the companies to put ASR based things in Indian railway station, and it completely failed because the background noise, you know, in Indian railway stations is something that those models had never seen or handled before. So yeah, that's a fair point. So Professor Shashi, your focus is on scientific models, right? Like to advance scientific capabilities, etc. In what I would call the West, there have been a lot of very significant breakthroughs using you know, generative AI in the field of biomedical things, for example, genetics, material sciences, etc. So how do you, this requires quite a lot of deep research and scientific data. So do you think to build a scientific, like how are you even going about this architecturally as well as data-wise, like so that it actually is something that India can benefit for, if not in the very short term, then in the longer term?
Sure. So first let me explain, or at least try to, on a high level, what is really the scientific foundational model that she's talking about, or what we are trying to build. So if you look at the existing large language models, these large language models are mostly like probabilistic based, next token predictions based on the probabilistics. But what is the biggest challenge is importing the scientific knowledge. And for example, I want to have the response should be physically consistent, mathematically verifiable. So those type of constraints, you cannot put it in the existing large language models because it is not meant for that. On the other hand, what scientific innovations or scientific discoveries we really need is the response that we are going to get from these foundational model really should have like the physically verifiable responses, and as well as sometimes the causal responsibility. I need to have the reasoning out. So it is temporal and as well as the spatial inferencing should also be validated. For instance, when I increase the temperature in particular location, right? So how this reaction is going to be, right? Reactives or nucleation is going to be. So these type of reasonings are ingested into the large language models. So when you want to bring such a type of responses, then definitely we need to build a foundational model which is also of a scientific capability, physical reasoning capabilities. So what I see from the architectural point of view, of course, the transformer is exceptional, doing well for linguistic applications. Whereas when it comes to the reasonings, especially the scientific reasonings, what we are missing is more of like the symbolic reasoning. What we are missing is, for example, the encoder type, specifically for the equations or the mathematical formulas or even the physical relationship. So the encoders that's exclusively for encoding the equations. For example, if you go to the Navier-Stokes equations, if you take the energy equations, you cannot mix match. It's not the next term. Next operator is not a probabilistic operator. There is a physical meaning to it. There is dimensionality analysis comes into it. So we cannot, the encoder cannot go is convert the set of equations as a set of tokens, but we have to embed the physics into it. So those are the challenges I see are missing components in the existing transformer models. This is where at Zentic we are really focusing on to add to these transformers so that, and then I bring the data set of a scientific data set, either synthetically generated. So even to generate synthetically, what I really mean is scientifically computed data set. It's not like hallucinated or generated from the LLM models. So you have to create the data set from the physics informed approaches and use the data sets, train on these enhanced transformer, enhanced foundational model architectures, then we will be able to bring the capabilities. So why we really need, why are we looking from this perspective? For instance, India, it's, when you build about the foundational AI for India, it cannot be about only for languages and the general purpose applications. Of course, those are very much needed, but we also really need to take care of how to accelerate the scientific discoveries and can AI solve the engineering problems. And if you look at India's major challenges, biggest challenges, I would say that right now it's energy, EV we are talking about, and then how can I accelerate the advancement in the engineering, manufacturing, right, climate, and you keep on material discovery and so on. So those are all the challenges, right, that could be addressed with this foundation model. This is how we are really building it.
Yeah, I completely resonate with what you're saying about like India's challenges and a lot of, because you go and talk to people who are in the manufacturing field, who are working in industrial things, and a lot of them are still very unsure of how they can use AI beyond kind of like a user-centric productivity tool, but like in a deeper sense. I will come to this whole deep tech kind of a thing later, but Vivek, you've seen it all. You've seen how, stacks are built in this country. You've been involved with Aadhaar in the past. You've helped build, the India stack, the first India stack, if I may say so, kind of. So what, according to you, in AI, like, what are the things that you can actually bring in from your earlier experience, but what are things that are absolutely new when you start thinking about building an India stack, based on a foundational model that, like Sarvam is building?
So I think in the last 15 years, we've done lots of interesting things in the India stack and building, creating some of these population scale systems. I think the interesting thing is, I think AI is somewhat orthogonal to that. In fact, but the fact that these large scale systems exist means that if you actually build the right kind of AI, these things can accelerate, the adoption of these things can accelerate them dramatically. If you look at what we did and actually Aadhaar is somewhat of an exception because actually it is DeepTech in that sense, but most of India's stack is actually creating the data pipes, defining the interfaces, and scaling things so that these various systems can talk to each other. And when these systems talk to each other and think systems exist at scale in the country, you can actually bring out new things much faster. And AI is an accelerant to this. And I think that if you see that in each one of these systems, I think AI will play a very significant role. But the fact that these systems exist will basically allow, and I think I resonate very much with what Anant has said, right? The reason that we have to get every person in the country leveraging this technology, because it is going to make a difference. We talk about the digital divide, right? The people who don't have access to digital technologies and I think the AI divide, if we not careful, can be much worse than that, because we all know that in our lives we can have significant efficiencies and improvements in what we do. But then that needs to go to everybody. And the promise actually should be, right? How does everybody get access to good education? How does everybody get access to high quality health? And I think some of the systems that we have built, that thinking and leveraging AI in that concept is actually something that combination, for the first time we see that, I can see that light in the tunnel, that life can actually be simpler for people, right? I think we are not there yet. Trust me, we are not there yet, despite being in sync. But I think that I sometimes say that, in UPI, for the first time, we feel that something is better in our country than, in other parts of the world. But most things are still hard. And I think AI has that opportunity to make that simple for everybody in the country. And that's where we must focus to how do you actually make this impact happen.
So I was in this first session, the inaugural session, and, I was listening to the panel there, and Priyank Sarup made a very interesting point, right? He said that we need less of unicorns. I'm paraphrasing him. He didn't exactly say that, so don't quote me, please. But he said something to the effect that, unicorns are not the thing going forward. We really need to have deep tech focused startups, right? And I've, in my conversations to folks around this whole ecosystem in India, there seems to be this thing of like, let's not only solve use cases, but let's kind of solve deeper problems, which goes back to what you had earlier said. And you know, my view on this also is like if in 3 years or 4 years time we are still solving the same use cases, then we have in some sense failed, because we should have like solved those use cases by then, right? So in that sense, where do you think, if like we did have this patient capital that everybody is like talking a lot about, in each of your fields, like each of you, if you can answer this, where do you see like this deep tech focus and this patient capital helping you take the technology forward, not just solving, like not just making more applications per se?
Maybe should I start? Yeah. So I think maybe I'll go back to the previous thing. I think the important thing is not to focus. While use cases are very important, they actually show how something is useful. But I think having platforms is something that where you can actually see that how you can actually scale and do things, greater things over time. And I think obviously when you're trying to build more foundational things, it does take time, it does take money, and I think that I think India is I think both of those. I think some of these things are changing. There is obviously more funding for deep tech than before, but still I would say orders of magnitude less than it should be, because these technologies are so important, right? I mean, I think that I think that while many of the things that we've done that have done are good, but even if there could be even a couple of orders of magnitude more, right? I mean, for a country of India's size, there actually can be much more. And when we have to figure out how to make sure that those things actually happen, right? I think capital is definitely a key to understanding these kinds of things, because it gives you the freedom to solve the problem in the best way, rather than give the band-aid solution for the for what you need to actually make revenue the next quarter, right? Which in deep tech is very, very important, because in the long run, those which have the solid foundation are the ones which are going to be successful.
Yeah, so maybe I will put the previous phrase in a different way. When I talk about the unicorns, yes, you are right, but I took it like we have to build a unicorn, but the value should be for your product, not an inflated 5x, 10x. So this is where we should really build a unicorn, right? The product should be actual value, right? That's the value that you are to build. Coming to the funding, yes, of course, there are always challenges, especially in the Indian context, to getting into any new technologies, getting the VC fund, or even to start such a type of which really, one is the compute, second is the talent, and third is, for instance, the huge capital. These three are biggest challenges. Of course, if you look at the Government of India initiative, especially India mission, I would say that icebreaker, I would say. So there were the hesitation from the Indian VCs group as well, whether we should invest or will this technology will be quickly taken over by the US or other countries so that our investment will go. But the bold move from the India mission to, yes, we are going to initiate it, and then those initiation, I would say the first step, I believe that it has opened the doors for many, and I see at least now some support from the VCs to such type of deep tech startups. Of course, the deep tech startups also really need some time. It's not like 3 years, quick services kind of sectors we cannot expect. And that's the reason, for example, RPOC is one of the examples where we are incubated. So we get the seed grant, and then especially the lab support and also the advisories. So patience is the key, but at the same time, as you mentioned, 5 years, some product, right, we should really focus on, especially when it comes to the deep tech. And if you are looking at the service as a deep tech, I see a big challenge here.
Okay, I have a contrary view to all of them. So India, by our culture, if you look at R&D spends of any large corporate, I bet it is less than 3%. So India is a value-driven market. Yes, there has to be a large capital, which is a patient capital waiting. But in India, it is not accessible to most of the startups. I think what has worked for us, I mean, we have been profitable, we have been successful to a small extent. is, as I said, we took a use case. But to solve a use case, either I can be a wrapper on some API or I go invent. That's the innovation. So India looks at value innovation. So if you are innovating and you have a long vision of, say, I'm building something fundamental which can add value. It can be used for one use case, but it is creating a platform that I can replicate into 10 other use cases, right? That sort of fundamental research in India has money today. At least this is my experience of trying to pitch to multiple VCs in the country. But I think, and this is what has been in our culture, like in India we look at frugal innovation. I mean, this is worked as in multiple cases, things that what DRDO and ISRO have done at far lesser spend than what global companies like NASA or SpaceX is doing, right? I think India has an potential to innovate. There is now, as he said, India AI for us is also a boon that we get close to 1,500 odd GPUs to pump up and run our models. So this sort of government waking up and saying, hey, I need to support startups to do. I mean, this is something that's happening great. It is changing. But again, for that to become like in the West, like you go, you have an idea, you raise 30 million with an idea over a deck. I don't think India is going to get there in next 10 years. India requires value. Every pie is measured by the value it gets out. I think this has been culturally what the country is, and I don't think it is going to take a tectonic shift in next 5 years. We might cry, we might do all of those things, but finally when someone is putting a rupee on table, he's going to ask you, boss, what is my IRR, what is that I'm going to get? They're ready to wait as long as you're showing value. I think this is completely, as a country, we are looking different to what is in the West. So I think this is my view on it. Yes, as you said, there is huge need for capital, but capital comes where there is innovation and a value. And probably you might not see free money coming in. You might do first round, but you will get stuck in second round unless you show your value. So I think this is where I see where the...
Of course. Now, just to change tracks a bit to my favorite topics, which is evaluation and then safety. So starting with you, Anand, because like you've been doing this for a long time, and I'm sure you're as frustrated as I have always been with word error rate as any benchmark for anything, right? People still talk about word error rates, etc. So and there is no easy way, to evaluate Gen AI models, right? Like applications we can do, user things, etc., etc. How do we evaluate models? So how have you gone about, not just on the accuracy, precision recall kind of measures, but also on the impact and usefulness kind of a thing? Like, how do you evaluate? And this is a question to everybody.
Sure. I think a lot of our, the way we started, when we started, we were talking WER benchmarks to everyone. It made no business sense. At least what we do today is we run some sort of field trials. Field trials can start within an enterprise or it can go out. And then we see a business outcome to it. There are technical challenges, I'll get into it. I don't want to get into the accuracy errors. Those are things that have been measured. But typically, what is the impact that it creates? We were doing a campaign where we used to help mothers in different trimesters of their pregnancy with like an intelligent voice bot, and this was run in UP, multiple villages, right? The impact there was, hey, I had this question, did your assistant answer? So then we said there were some challenges initially. On the back end, this was multi-phases. In the first phase, we had a bunch of doctors who used to feed in the answers. Then we used to do an outbound call back to the patient and said, hey, this was your query. So at that point, we were just doing a transcription, capturing the audio. This is like 4 years back what we did. And we used to relay back them the answers. That led us to build a questionnaire bank of 1 lakh questions, which people ask across different phases. What we did then is we made ASHA workers more intelligent, enabled this set of questions to them. And whenever there were a meeting between mothers and ASHA workers, they used to call together and get answers. So the impact here we measured is on this set of questions, what is the accuracy level that I could give back, whether my answers were deterministic. So you could go into technicality of saying hallucination, this one, but that's a different problem to solve. But in use cases like this, it is like, how accurate is your system able to understand even the question is half broken? Can you communicate back a pre-vetted answer which was given by a doctor? So based on different applications you deploy, we see various measurements coming in. But fundamentally to the core, it all boils down to your word error rate, how do you handle noise, what is the hallucination factor that is coming in, how do you contain the RAG on your data set, things like that, for which we have some deterministic benchmarks that you keep running. But from an end user perspective, this is what we have been doing in the past, and we do. I think with this we know fairly that wherever I am confident, also in some cases we do a mix of confidence-based answer. Wherever I am not confident, I try to bring a human in loop, or we say we'll get back to you. So that, again, it depends on use cases again. So you can configure your system to handle scenarios based on this.
So Vivek, I would like you to answer this in a different way. Like, earlier, the benchmarks and the evaluation things that we ran, they had very little India-specific content, right? And the benchmarks got contaminated the minute you used them, right? And the thing to make them India-specific was to just translate those into Indian languages, which also did not work. Yeah. But now, just recently, OpenAI has put out this India Q&A. AI for Bharat has put out the, the arena. So, do you find those useful? Have you got your own thing? What would you want from people who are working in the evaluation space? What would be really useful for, foundation model building for India? If you had a wish list of sorts.
So I think, certainly what both OpenAI has put out as well as what AI for Bharat has put out are certainly improvements to what existed before. But I think the point is that still, I think there is too much benchmark hacking, right? In the sense that, and the benchmarks are not representative enough of real things. So, I'm actually kind of going towards, a little bit towards what Anand is saying, that, but I want to say it a little bit more formal way, that if you actually had something like you may have a base model, and then you have a use case, and you're looking at the distribution of data in that use case to actually leverage a benchmark, then that's much more meaningful, because then for that particular thing, you can understand whether the whether the business outcome really was achieved, right? Because, as I said, I think that, word error rate and character have no meaning really in today's world. And I think it is really whether the outcome was achieved or not. And I think that it's actually now much easier to create an in-distribution benchmark for a domain or a use case specific situation. And then you use that to measure the performance on that. I think that's probably the most effective way of saying that there is actually value to the end user in using the model, right? And so therefore, therefore, having more narrow benchmarks, right? Well, I think I think that we have whatever, the equivalent of all the standard benchmarks in Indian languages should be there. That's a I would say is hygiene. We need to have that, and unless we have that in languages, that will also direct the direction in which people are going. But I think having actually much more domain specific and intent specific benchmarks. Even you look at, when you're looking at conversations and things like, you look at things like tau square bench and things like, even they are not real as to what really is happening. So therefore, I think, we actually create benchmarks too, so that we are not flying blind in these kinds of things. But having everything in Indian languages in the idiom is something that is obviously much better and also much easier today than 3 years ago.
That's absolutely true. Professor Rashid, for scientific models, the benchmarks are at a different level altogether, right? They're much more complicated. There's a lot more reasoning, inference, etc. involved, right? Like, so how do you benchmark or propose to benchmark what you're building?
Yeah, so when it comes to the validation and benchmark and as well as the safety, that's another point that you talk about. So I will take one by one, right? When it comes to the validation part, first of all, we have to understand, right, any AI model or any AI system that you are building is an iterative process, right? So that the one component compared to the traditional software development, compared to the AI, what's an additional component that's part of the AI component is the continuous monitoring. So we need to have a continuous monitoring mechanism. Then we talk about the concept drift, data drift, and that's where the validity of the model comes. So when you talk about the accuracy and the validity, it is the responsibility of the developer, right? So then it's a continuous process over a period of iterate and build. On the other hand, when it comes to in particular to the scientific, how to create the benchmark, how to validate the model, though its outside world looks very complex than the LLMs and so on, but actually it is not the other way around. So the validation part comes from the physics. So if at all the response which I'm throwing, or any response coming from the foundational model, whether it's confined to physical laws or not, whether it satisfies some certain dynamics or not. So we have already proven dynamics, proven physics behind it. So only thing is, like, based on that application, we have to develop the benchmark data set, benchmark data to validate that. So creating those benchmark validation is not so complex as the language one. So this is where I see it, right? We have at least some edge or advantage building the data set. On the other hand, when it comes to the safety part, right, safety is not only the developer's responsibility, the user's responsibility also. We can build like whatever the equipment and whatever the model that we build, but the question is how the user is going to get used to it and for what the user is going to use it. So when it comes to the safety part, then it's a responsibility of three groups or three entities. One, of course, the developers must put some guardrails so that it cannot be easily broken, AI models cannot be easily broken and so on. The second responsibility is as a user, right, I should be educated for what I should use, what I shouldn't use. And the third responsibility is what is the policy, right? If something goes wrong, something has mistaken, so what's the policy to that? So it's basically this, when it comes to the safety, it's a tripartite responsibility from the government, safety policy, AI policy, and as well as the user's responsibility. So the benchmarking policies and safeties put together, right, I think we really need to get it evolved over a period of time. Then only we can think about the benchmarking and safety over a period.
Thank you. I'll open it to the audience for a couple of questions before I ask my last question. Someone here with the mic? Yeah. Can you people around who want to ask questions, apparently? It also, yeah.
Hello, is it audible? Is it audible? Yeah. So considering recent Sam Altman's remark, it's a totally. How about now? Yeah. So considering recent Sam Altman's remarks that it's totally hopeless to compete with us.
Please
on Yeah. How about now? Yeah, perfect. So considering recent Sam Altman's remark that it's totally hopeless to compete with us on the training the foundation models or something like that. So what is the biggest challenge in building the foundation models? Be it cost, compute, or talent, or the core tech stack? So what's the thing and why?
I think all three you said.
Yeah, all three is the answer.
It's unanimous, all three.
Hi, thank you for this really interesting talk. My name is Sugandh and I'm the founder of an edtech startup. My question to you is that given the shift in how we are approaching or looking at AI models, from it being an efficient AI model to being, is it an innovative AI model? So from solving for redundancies to now pushing the frontier of human knowledge, that's the arc that I observe in the way AI has changed over time. So given that shift, where do you see it moving next? Where does it lead us next?
So I don't know, I don't know how to, that's a big question, but I think that I personally believe that everything we do is going to change. And I think that, no matter what you're doing, it's going to be completely different 5 to 10 years down the road. I mean, I think that's how the scope of it, you are entering a brave new world, so to say.
But, and also if you need a popular answer, of course, we are moving towards the AGI. All right, so that's the direction. But the other hand, artificial general intelligence, basically, right? So on the other hand, right, these AI skills are going to be like, for example, 20 years back, knowing typewriting, or people used to go, right, for typewriting classes certification. Typewriting is a basic skill, or additional skills one used to occur. So after this laptop, computer and other thing, nowadays like typewriting is no longer like an additional skill, it's a default skill. So similarly, what I see is the AI, today it looks like I have to acquire this additional skill, taking some upskilling and so on. But where I see is when it starts mingling, when it starts integrating with our day-to-day life, I'm going to see that AI, whatever we are using it today, it will be a default knowledge that we should acquire. This is where I think in an immediate time or immediate thing we are forcing and moving on.
Yeah, sure. Am I audible? Yeah. So thank you for your talk. My question is, myself, Dr. Pavana Pradeep. I have PhD in postdoc from USA. My question is for Dr. Vivek Raghavan. So along my research, right, I have been reading about these fascinating LLMs. Along with that, I have been studying about the carbon footprints of these LLMs, like enormous data trained and even at inference scale. So my question is, how does India's foundation model, like from Swaram, is taking initiative to reduce these carbon footprints and making Swaram as an ecosystem,
No. So firstly, thank you for your question. I think it is definitely a relevant question because, as you see, people are building bigger and bigger data centers around the world. Maybe not so much in India, but I think the focus that has actually been happening is that, and from a model builder focus is, what is the strength you can build with a model as small as possible? And we are getting more and more efficient about how the models are, both in the training of the models as well as in the inferencing of the models. So compared to, say, something a couple of years ago, we're probably at least an order of magnitude more efficient. And then you figure out what is the right size of model that you need to actually solve what kind of problem. So many of the problems may happen in the edge. So I do believe that there will be a lot of innovation that will focus by this thing on how to make these models more efficient in terms of more energy efficient. And that typically also means efficient in terms of cost and other things. So I think that will happen, but there are two sides, right? The other side, we're building bigger and bigger models, and I think that, but I do believe that I'm not one of those people who believe that this is going to hit an energy singularity here. Yeah.
Thank you.
Just one last question here because we are out of time. Yeah, just one.
Hello everyone, very good morning. I'm Saravana from Superdome AI. I'm the co-founder of Superdome AI. So the question here is, one side we are talking about building a super big models, LLMs, and having 80 billion, 1 trillion parameters and all those things. But on the other side, when you're going to put all the knowledge into single model, and at the end of the day, we are going to build some applications for some particular use cases, some industries, right? So there is a concept of SLMs, right? Small language models. So how we are going to diverge from, so one area we are going to make the LLMs stronger and stronger. Meantime, when you're going to build some agentic apps, we need a lot of SLMs, which lot of knowledge on that particular domain. So how the foundational model teams are going to approach that, and what's your take on that?
So I can give an answer of what we are doing. So within banking domain, which is where most of my business is, we have come to sub 1 billion parameter models. We do it, we call it as our own SLM models. So essentially, there are two phases to think, even answering her questions, right? One is you build larger models. Within larger models, again, you have a model of experts that you are trying to build. I think strongly we go with that mode where you have experts trained for certain specific data or specific tasks. Same on the SLM side itself, you bring in with certain capabilities distilled out and again sort of fine tune or adapt it to a particular domain, and you can, that's a model of expert for that domain, which can coexist in your larger model, but you can also have a version. And it's not only for an application specific, but you see a lot of things evolving on the edge. So this can go into your edge devices like phone or handheld devices, even your laptops, etc. So there is a lot of work happening on it where you contain your training data, you contain the capability of it, etc. and build it. I think a lot of research is happening on it.
So basically when you're training your foundation model itself, you're also thinking of how this can be broken down into multiple SLMs?
Yes.
Yeah. So one way to do it, one way to think about it is that, you always can take a large model and distill it into a small model, especially if you are narrowing the domain of what your task is. But the point that you want to do is that if I'm an application builder, I would typically try to set up my applications always easier to use a larger model to begin with. But if I know that I'm going to use it millions or billions of times a day, I better make a small model to actually make that happen efficiently. So these are standard things of distillation of models. Is something that especially when you see that something is going to become high volume, then you end up doing those kinds of things. And kind of automated methods of doing that are also very key to actually building efficient agentic applications.
So we are out of time, so I just have one last question. Everybody, just one sentence. In 5 years' time, what is that big technological problem that you think India needs to solve to be at the top of the AI ladder? Just one sentence.
So to me, right, especially when it comes to the strategic applications, the defense and the strategic applications, we should be independent of foreign technology. And through AI, I believe that we can become an independent nation in terms of the dependency of the foreign technology for the defense applications. This is where I see it's a primary achievement that we can do it in the next 5 years.
I kind of agree with Shashi, but I think what I'll say is that this technology is so important. If we are giving access to this technology to all our citizens to do everything they need to do in real life, that is really the success of it.
I would say, I would dream that every citizen would have his own assistant, which is completely personalized to him. It could be physical, it could be virtual, but I'm talking including a humanoid. Like it could be as good as that. I think you'll see, it could be a device that's your assistant that understands you better than anyone, and it helps you with everything you do.
Thank you Anand, Professor Shashi, Vivek, thank you everybody.
Thank you. I request all the audience to give them a big round of applause for all the panelists for the very informative session. So may I now request Srimati Kalika Bali to present a memento to Dr. Vivek Raghavan, the co-founder, Sarva, may I? I also request Madam Kalika Bali to present a memento to Professor Shashi Kumar Ganeshan, founder Fintech and Professor IISc. I request Mr. Anant Nagaraj to accept a memento from Madam Kalika Bali, the co-founder CTO Gemini. I request Dr. Vivek Raghavan to present a memento to Madam Kalika Bali. Thank you once again. Thank you, sir. Thank you, ma'am. So, ladies and gentlemen, now we are moving forward for the next panel discussion, that is Industry 5.0 and Robotics.
Across the last 18 years, it's very opportunistically done. If you really ask me, because in 2006, 2007, when we started investing, there's very little in terms of industrial or AI and any of those kind of things. And my background itself, I came from manufacturing, so. From the funds perspective, I started looking at robotics very, very early. And the journey has been very, very interesting from Fund 1 to Fund 5, where we are today looking at very specifically allocating maybe 12 to 15% of our capital into deep tech investments. And these are across few areas, some of them in the advanced manufacturing space. We are looking at which will have industrial AI specifically around that. We have actually invested in one company called Frings that is trying to do something in the automation space on the industrial side. We've invested in a company called -0, which is around automation. And you'll talk about it a lot more. But that's an area that we think is very, very interesting. We've also invested in robotics. Right now, it's very interesting. While we have not invested anything on the industrial side, our investment is in a company called Miko, which is the consumer robot. Right? Again, it sells specifically in the US, given the price points and so on and so forth. So, few things that is, I think, specifically different for us in this time frame is the fact that our focus around deep tech and industrial has gone up significantly. 12 to 15% of our capital would go into some of these areas. And also, these are, we believe, emerging areas in India, which if you take a 15, 20-year view, will be extremely critical from a sovereign perspective as well. So that's really where we are, and we'll be happy to share more.
Thanks, Sanjeet. Naveen, I would like to hear your experiences in autonomous technologies at ATI and your perspective on it.
Thanks, Abhijit. Good afternoon, everyone, and it's a pleasure to be here. ATI, as a company, we have been working on autonomous mobile robots. We are a pre-COVID startup. When we started out, a lot of our robots were intended for automotive companies and automotive component suppliers because they were the sector that really took to Industry 4.0 first. Digitalization of their back end and more automation is something that is part of their fiscal budgets. But that has changed drastically post-COVID. A lot of these other verticals like FMCG, pharmaceuticals, healthcare, electronics industries, there's been there's a push for semiconductors now. So all these verticals have taken to automation way too hard. They realized there could be black swan events like COVID, and all of them are now customers. All of them have installed robots and adopted this kind of a technology. So that's something that we see that Industry 5.0 is naturally happening in the physical AI space. Of course, in the industrial AI space, as Derek mentioned, and their company has been doing some phenomenal work. Ranjit's firm has backed like a lot of good firms in that space. So we see this is going to be a confluence of multiple things. There is going to be robotics, where humans and robots can collaborate seamlessly. And there's going to be a software industrial AI layer on top of it, which is going to make these things much more fluid. So that's the way we see how Industry 5.0 is going to be adopted across verticals. Thank you.
Thanks, Naveen. That's an interesting point. So I would stick to that, Naveen, and say, over the years we have seen the edge computing become cheaper. We have seen sensor fusions happening. We have seen such SLAM algorithms improving. So how do you see the future of robotic autonomy as we go along, especially in the context of Industry 5.0 and in the context of, I would say, Indian industries or MSMEs, where it's rather unstructured. The shop floor is rather unstructured. So that should be an interesting problem to solve.
No, that's a great question. As compute power is falling down, as you correctly mentioned, right? And also technological breakthroughs that have been happening the last 4 or 5 years. 6, 7 years back, the job was very different. The robots are supposed to do their functions, but don't hit anything. Be safe. That's about it. But now it's more nuanced, more evolved, right? Like customers are demanding that these robots have to operate faster than status quo. It has to work in tighter spaces. So all this means that your SLAM algorithm has to be top notch. It can't be some handcrafted, for people who are unaware, I should explain what SLAM is. It's one of these slightly harder problems in robotics where the robot has to simultaneously find out where it is and also map the environment in which it is operating. This used to be somewhat of a hard problem, I would say 7-8 years back. Very brittle, handcrafted. An algorithm that works in factory X will not work in factory Y. But those things are changing now with the last few years, the research breakthroughs that we have been seeing. So the same algorithms can work in like multi-season, different lighting conditions, different factories which have like long tunnels, factories which have like outdoors. So they seem to be doing pretty well. And as Abhijit correctly pointed out, it's largely because the compute power has been falling down. So you can do a lot more things on the edge. And as you just alluded to, Indian environments can be quite diverse and quite unstructured. A lot of things that, you know, if you get your robots to work in India, the joke that we have in Athi is like it should work anywhere in the world. So that's like an edge that you get to do as an Indian robotics company. I think I can stop with a joke where in our first deployment, where we absolutely didn't anticipate it, a stray dog crossed the robot. We had no idea that such things can happen in a factory, but it happens, and you become wiser for it. Just in conclusion, both perception and SLAM has evolved over the ages, and it's largely because research has caught up, and also because compute has caught up.
I'll just add to this. It's interesting. Many years ago, we backed this company called Perfint. It was a medical device that was focused around minimally invasive surgeries, especially around ablation and stuff like that. And when the robot hit the market, which is the hospital started buying it, they figured out that over a 5-month period, the calibration of the device was just going for a toss. Okay? Turns out the doctor was hanging his coat on the robotic arm, right? And, over a 5-month period, the calibration goes because the coat is just hanging all the time, right? So, I mean, the conditions here, because there's no standard operating procedures on a lot of these things, it's extremely challenging building solution for India. And like he's saying, if you can build for something that can work here, obviously it can be very useful all over.
Thanks, Sanjit. I'll come back to you, but to Derek, on the same lines, what I was talking about advances in edge. Indian industries are seeing a lot of digital transformations with probably sensors being put on shop floors, machines, people. Are we moving from, regular maintenance or reactive maintenance to preventive and predictive maintenance? And what are the challenges do you see, especially in that context?
Okay. India is a very tough market. The willingness to pay is very low, I would say. But if you look at it, so I'll start with where the demand lies and then follow it by the tech part, which is to support that. So we experimented with a lot of industries out there to predict the health, predict the failure of equipments. I think there were pilots which we did, many of them free, but really did not see scale from an economic perspective as a startup, right? And for us to survive, cash is very crucial. But having said that, I think the Indian market is responding to 3 problems right now. One is in the energy sector, if you look at it, especially refining industries. Corrosion is the cancer for a refinery, right? So we import crude right from Kazakhstan, Iran, variety of places. The chemical composition is different. It corrodes the pipes, right? And they spend crores of rupees, hundreds of crores of rupees in corrosion prevention and essentially treating that. It's always a response, a reactive thing. So they want to move from a reactive mode to a more proactive mode, and there are a lot of, for example, hyperspectral imaging of pipes is one area which they're exploring to see, can they detect changes in the chemical composition of the pipe before it gets very adverse, right? An electro-optical AI can only detect the brown color formation after it's too late, whereas spectral changes can be detected earlier. So that's one area where there is a willingness to pay because the intensity of the pain is very high, the value unlock is very high. corrosion is one area. Second area, of late, we are seeing is there is a willingness to spend on emissions. So corrosion and emission related areas in the energy sector, I think two areas where I think the Indian market responds to. So if you look at the emission itself, right, carbon emission, methane emission, there is a lot of need for gathering data from drones or from satellite to understand the chemical profile of a refinery from which you can extract how much emission is happening and to do compliance reporting and stuff like that. So those are the two areas on the energy side of things. The second area where you're seeing is manufacturing, not the discrete so much. Our area has been more on the process chemical side of things. So where a lot of fluids come together and you know, there's a recipe for cooking a chemical, so to speak, right? It's like your grandmother's secret recipe. You have to heat it for so much time. You have to pour the secret. So the recipe of a golden batch has to be unlocked from the existing processes. And there's a lot of AI to reverse engineer the recipe of a golden batch and to make sure that you're able to predict deviations from baseline behavior. So if you look at it, pharma industry, process chemical industry, anyone, kinds like Henkel, etc., in the Gujarat, Bombay sector, there's a lot of need for that because the cost of a rejected batch is extremely high. And of course, the third area is defense, I would say. But in all of this, I think a common denominator from a technology point of view is, I mean, you have two ways of sensing. One is a very invasive way through sensory data. The other is non-invasive. Given that most of our assets, electromechanical assets, are not instrumented, I think there is a propensity to go the non-invasive way from a technology perspective. Yeah.
Thanks, Derek, for that perspective. Now that you know, both Naveen and Derek have spoken about the technology part, Ranjit, to you the question would be, as an investor, wearing an investor's hat, do you see we have reached an inflection point, or we are more at still a very nascent stage where a lot of work still needs to be done? How do you see this ecosystem evolve?
Yeah, I think the answer is yes. I mean, and I'll tell you, it's more from the demand side, right? One of the first companies that I was involved in from an investment standpoint was a company called Connectem. I don't know if you remember it, but you know, this was a company that was trying to do something in the M2M space. It used to be called machine-to-machine communication, where you know, one machine will talk to the others, and you know, I mean, I made the thesis saying, you know, in a 5-7 year time frame, all the machines in the world will start talking to each other. I'm talking 2007, okay? And we invested. I mean, the company took in, I think, $6 to $8 million, including, you know, some very strategic guys like Sasken and IBM were investors in that, and it was a very strong thesis on paper, right? It's been 15 years now, or maybe more than that, right? And still we're talking about early days, right, of this business. So I think we've, you know, it is still early. I think that the answer to that question is it is early, and it is not so much from the technology side. Obviously, like he was saying, a lot of things have changed from the technology standpoint. We were, you know, using very small sensors to figure out how machines were operating. Edge computing has come, the cost of compute, the speed at which compute can be done. All of this has significantly changed and makes it a lot more easy to build stuff, right? I think the challenge really was on two fronts from a startup standpoint, and again, that's where a lot of my time is, you know, spent, is two areas. One is in terms of adoption of this piece of tech by the large enterprises in India as a customer, and that's very, very difficult because, I mean, all said and done, labor is still cheap in India, right? And so anything to replace that piece takes a lot of effort and convincing. I mean, it's one thing that, like, I think there was this conversation earlier, there's a very top-down approach to this, right? I mean, because in the top, everybody understands the value for this, sees, you know, automation is a big thing for the future and so on and so forth. But as this comes down to the shop floor, there is tremendous resistance in terms of adoption of some of these technologies. And that's really, when you talk, as a VC, when we talk, we really like the piece of tech, the working model, the team is great. When we talk to customers, and when we talk to, you know, part of diligence, we talk to the senior folks who buy, and then when we talk to the people who actually use this stuff at the bottom, or anywhere in the thing, it's a very different story. So I think that is really a gap that needs to be sorted out, and we believe that is changing. And that is changing with AI. I think it's a very different proposition, and I'll come to that in a bit. The second one is in terms of supply chain of capital. Some of these technologies, till about very recently, got very little support from the VC ecosystem. I mean, today almost every VC is talking about DeepTech as a area that, I mean, we are saying we will commit 12 to 15% of our capital into DeepTech, right? I know we've been investing in robotics, like I said, we've committed $150 million with very little to see, to show for some of those things. These are brilliant pieces of technology that were built by great folks, but just couldn't see the light of day because they were too early. So that's the risk that you run. And one piece on the capital front, I think, is getting sorted, right? Given the fact that there is a lot more interest from the VC community into this domain. So you will see a lot more capital flowing in. There are, again, I mean, we need to be very, very careful about where we, from a VC standpoint, because we have a huge responsibility of returning back capital within a period of time and so on and so forth. So it is very important to making sure that we invest into areas where the market has also opened, right? And that is, I mean, those are specific areas, whether it is in space, whether it is in, you know, I think in the next 5-10 years, you'll see a lot more capital going into areas around semiconductors because there is significant push from the government side. And I think those make a huge difference. So to answer your question, I think it's still early days, given that we've seen this play out over the last 15 years. But I think the difference is that there is a significant change from the capital allocation standpoint, and also from the demand side, there's a lot more adoption of tech for solving a lot more problems. And this is, you know, we're seeing, if you look at any investor call, even in a publicly listed companies, the analysts are asking about what AI can do, which was not at all a question, you know, even 10 years back, as to what technology can do and so on and so forth, because it's really a top-down, a significant push from the top down, and I think that will make a huge difference in terms of adoption of some of these tech.
Thanks, Sanjeev. Keeping on that note, you know, like you rightly said, it is basically, you know, adoption on the factory floor and the technologies that are related to that. Just a continuation of that, how will you evaluate a startup who comes to you for funding, who has an Industry 5.0 offering? Do you look at the maturity of tech stack? Do you look at ROIs? Or do you look at acceptance? Or what is the kind of metric? It will be very interesting for the audience to understand that perspective.
Yeah, so I mean, again, putting this question into perspective, in the last 12 months, there are about 4,000 opportunities that hit our system, 12 to 15 month time frame. So, and we've invested in about 7 or 8. So, okay, I mean, so the chances that we can get this wrong is very, very high. Okay, but having said that, right, what are we looking for? We're looking for very smart people who can solve some problems that are extremely large within a time frame, right, of 10, 12 years, right? Because it's important, like I said, all fund lives have a certain time frame, and this is the challenge that has been in general with deep tech. The gestation periods for some of these companies are very long, right? And it requires significant amounts of capital because it takes longer, whether it is in AI, whether it is in, I'm not talking at an applied AI level, but anything below it, right? Below the stack, I think, takes a lot more capital. And so it's always been, which is why the challenge has been around funding some of these businesses, right? And the average age of the guy, again, I mean, the founder that we are backing today is about 28, 29, okay, order of magnitude, right? Which completely, you know, questions the kind of people like me who are like extremely old around this, right? But I think the way to, what we are looking for is, especially around deep tech, right, is one is your understanding of why something will work. I mean, there must be some insight that you have figured out based on your experience in a certain domain that makes it work. That is extremely important. Second one is, you know, one of the things that we figured out, like moats. I mean, there are a lot of these conversations around what's the technology moat and all of that. But I really think, given the pace at which technology is changing, the moat is really the quality of the team that is there, right? your understanding of how the technology landscape is changing and how you can attract the right kind of people to kind of, navigate that changing landscape, I think is significantly important from our, investment thesis perspective. Then, of course, there are, we deploy third-party folks to do diligence on the IP landscaping to figure out it is not, conflicting with somebody else. I mean, there are a bunch of those kind of things that happen across, but I think fundamentally it is about a problem. And then, like I said, we also speak to potential customers, where they are in the buying journey, because this is very important. See, one of the things that we have figured out is in India we have significant talent that can build something. There is that not enough talent that can sell what they've built. And we were having this conversation, right? And that's also an important thing. So if you have a set of founders who are extremely good in the lab building something out, then how do we are they open to getting somebody else around who can actually tell the story, and pitch this in the right form? All of those, I think, and that becomes extremely critical when we talk about deeper tech and some of these areas where it is physical in nature, right? I mean, it is so, your buyer is physical in nature. So how do you tell a story where the product is physical and it's still not there for you to demonstrate and so on and so forth? So I think those kind of things also become an important element in our evaluation process.
Thanks, Venki. To both Naveen and Derek, probably Naveen first.
Start with basic condition monitoring. Then you go to diagnostics, prognostics, and then go to autonomous. But the jump from diagnostics, prognostics to autonomous, it's not only a technology issue, it's also a trust building issue, right? You have to earn the trust of the field guys, basically. So if you look at, from an Indian perspective, like I'll just take one industry, energy industry. If you look at the lowest end of the value chain today, Shell out of here is, Devanali is monitoring the health of all the motors globally. Chevron is moving all the digital refinery operations out of Bengaluru. ABB, for example, is monitoring the energy guzzling and bad actors in Germany for a couple of infrastructure assets out of Jalali. So if you look at just Bangalore itself, Devanali, Jalali, Bengaluru, people have started doing basic industrial monitoring, babysitting machines, so to speak, out of India, which is digitally connected, right? So that is the lowest part of the value chain where we are working in. If you look at the highest part of the value chain, which is completely autonomous operations, there are companies out of India right now for subsea operations, Gulf of Mexico, drilling operations, 2 miles into the water and stuff like that. If you look at it, it's almost like the World Trade Center of digital operations, large infrastructure, independent power operations, etc., etc. Now, if you look at the problem they're facing is they have like 40 or 50 operators who are continuously monitoring exceptions or alarms, both subsea as well as surface. And the challenge is, it's like what an ICU nurse faces, right? If you're in an ICU, if an alarm comes, you do not know the priority of the alarms, right? And typically, if a nurse goes to the wrong patient, the other patient dies. A similar problem exists today in the industrial sector where the operators do not know the value of the alarm in terms of how quickly. So there is alarm flooding, right? And so we have started moving into, let's say, in 8 to 10 minutes, an inexperienced micro operator actions, which has never been mined. So today, we know companies which are actually mining the action logs and telling which action pathway or recipe is ripe to stabilize a process, okay? So the tribal knowledge is getting harvested, okay? And we are able to kind of close the loop there. So companies out of Bangalore, and this is probably the best unkept secret, is that we are operating on both ends of the value chain, both at the basic condition monitoring for the energy sector to the autonomous operations. And for this to happen, it's not just, I think AI is the shiny toy on it, but what is really required are two other equally important but unglamorous elements. One is you need to have a very strong electromechanical knowledge. You need to know the physics of the asset, the RPM torque curves. I mean, not so glamorous, but so vital to the outcome. So you need data, you need domain, you need AI. If all the three come together, there is value unlocked. So domain is very important. Industrial domain is very important. And intimate knowledge of the data itself. How do you process high frequency time series data? How do you process spectral data, lab information data? And there's a lot of data wrangling which happens out of it. That's equally important, very unglamorous, but equally important for us to power the autonomous operations.
Yeah, that's a very interesting perspective. I'll stay with that. Data collection to make things autonomous, interpreting the data, I think we are playing a very important role out there. And Derek, you have seen both sides of the world. You have seen enterprise, you have been a startup founder yourself. You have also seen the global scenarios. How would you compare this with the global scenarios, putting India in context with the global scenarios? Is there the USP that we should look at? Are we ahead somewhere? Are we lacking somewhere? Your perspective on our global positioning.
Okay, I'll provoke Ranjit a little bit on this first before. No, if you look at investment so if you look at consumer startups versus industrial startups, right? I think the VCs have a strong bias towards consumer startups than industrial startups. I'll give you an example, right? So we were supposed to be one of the industrial companies which raised funds before we got acquired, and we raised about $7 million in funding totally. A lot of struggle. But if you look at our competitors, who were we facing in the marketplace? We are competing against C3, we are competing against Spark Cognition, sometimes G would be there. All of them had triple-digit funding. Okay, we were like one-digit funding, competing with people who had almost 10 times more funding than us. And I think, so that's a big gap we face. Okay, but in terms of capability, I really think there are certain areas where we exceed what is available in the US, especially around the fusion of the physics and the statistics part, right? If you look at the Bay Area, they have a strong bias towards the AI side of things. If you look at Houston, they know the electromagnetic, but the two don't combine together. So whereas in Bangalore, we have the graceful mix of gray-haired people who know the physics and the ponytail guys who know the AI. We can kind of do things together a lot. So you're seeing the advent of a lot of GCCs which are capitalizing on the talent. Definitely the product guys will take shape out of it. So capabilities-wise, we are there. I think funding-wise, we are not there.
Ranjit, that's a cue for you to pick up and...
No, I think this is, like I said, I mean, VC bashing is like a very normal thing when it comes to some of these areas, right? Like I said earlier, consumer, we are a consumption story at the end of the day from an India perspective, right? And 1.4 billion people need access to good education, healthcare, you pick anything. And our sense is, technology can play a very significant role in building better access, better price points, and so on and so forth, which is why you'll see a lot of money that is going into consumption stories in India. And even for our investment thesis, right? I mean, 40% of our investment thesis will be driven around consumption. What I think is different, and hopefully, this is a change that I think I've seen from the last, when I started doing this in 2007 to what we're seeing today, is that there are a lot more VCs who are open and are, openly stating that, deep tech is a very significant portion of their investment thesis. And I think, which is why I really hope in the next few years you will see, and this is, I have data to back this. If you look at the number of investments that have happened in deep tech over the last 6 months, right? Every quarter, the number of deals announced in deep tech is actually increasing every quarter. So there is, it's just not, lip service that the investors are doing. And from our standpoint, I can tell you in Fund 5, we've committed about 10% already into deep tech, and we will increase that. There's no question. It is just, and I think it's also a reflection of I mean, the question around talent has not really come up in any of our conversations, really around the market. And I really think that there is a significant change on the demand side with whatever, both the gentlemen are saying in terms of how customers are adopting some of the tech that they're building is really, what is driving investments into these. And we are also building into the investment thesis that this is going to take longer, right? And so whole periods will be around 8-9 years. I mean, so it's important to make some of these commitments early in the fund. So I think some of those also are, rationalizations that the investors are doing, and I think this, in 2-3 years, hopefully this will change.
Thanks, Sanjeev. I would rather for Naveen rephrase that question with respect to international innovations in autonomy and mobility. We hear many times this, that it's easier to hire the forklift drivers than get an autonomous vehicle in India, right? And then at the other end, you see Boston Dynamics and other people having very high-end offerings. How would you relate to this, especially in the MSME context in India? What kind of innovations we should look at, or are we comparable to Boston Dynamics? Where is the technology gap? A quick perspective in the interest of time.
Sure. I mean, yeah, we come into work every day to compete with the Boston Dynamics and MIRs of the world, right? Like, so that's definitely the goal. But they built their brand over like multiple decades. I won't worry about the funding part of it, but I would worry about the brand credibility that they have built over many decades. Especially their distribution channels is awesome. They have distributors in like 80 countries or so. Building it overnight is not going to be easy for any new robotic startup. So you have your task cut out, but you can do it. Our goal has been that we have to cost innovate in India because this is a cost-sensitive country. But you can't compromise on quality because we want to build for the world. So our philosophy has been to piggyback on that excellent manufacturing ecosystem that India has. We have TVS and Bajaj have made like fantastic two-wheelers that are a hit all over the world. So why not use that ecosystem to build your robots? Of course, the robots will not work right off the bat because EVs work for a different condition, but you need to fine-tune them for robotic applications. So in terms of quality, you can get the product done, but how do you get customer trust? So you have to invest heavily in like safety certifications, which are globally renowned. So that's something that you have to do as a robotics company. And I think you'll get there.
If I can just add, which is on this, I don't know if any of you have gone to SF you'll know how to get into a Waymo, which is a completely automated cab service, right? I mean, you get in and you just take the cab and go, right? Now we've backed a company called -0, which is building an automated platform for cars that can, run by itself, right? Now, again, this is two brothers out of Chandigarh. I think they're just out of engineering college, right? So my limited point here is, right, I mean, it is important to making sure that when we build these, we have, like he said, keep the global markets in the view as you build this, because regulations and all of that, I mean, it's a little bit more evolved in some other places. Now, there's also another thought process, right? Because the regulatory framework is not as evolved as it is in some other places, in India is lower on the spec, that there are things that you can get done here faster, right, than anywhere else in the world, and then you have enough proof points to show it works. So it works both ways in terms of how do you think about it, but any of these kind of technologies that you build, I think it's very important to keep the global markets in perspective and think about it from that lens and not just look at it limited to an India proposition.
Sure. Before we open it to the floor, I would like to touch upon one important point, that is of policy, governance, standardization. When Industry 5.0 consumes a lot of AI, what about the ethics of the algorithm? What about the data governance around it? Because your model will be as mature as your data. We do not have ways and means today to share data across industries for the right reasons. I would like to get the panelist perspective of this. What should be one focus area, starting with Derek probably, on data governance and policy interventions?
I'm a big believer in data plumbing because, similar to pipelines, you can't automate the need for a plumber, right? Plumbers are always required, right, to go and do that. You can automate the cleaning part of it with a robot, but the under the hood stuff, I think there'll always be. So my son was asking me, you're studying and a lot of things were getting automated. He was asking me, everything is getting automated. Design is getting automated. And I told him one thing, plumbing will never get automated. Data plumbing. On the manufacturing side, energy side, mining side, I mean, they got a lot of SCADA systems, OT systems, drone data, welding, radiological data. All of this is not organized in a fashion ready for AI. Okay, AI is good, but you have to create very structured data products which can be ingested by the agent. So that whole data prep and data factory, cooking factory is not yet there for industry. So even if you go, I think creating pipelines around sensory pipelines, vision pipelines, it could be even a technician who comes on a shift. Today, if you look at the shift log, right, they write on a piece of paper and keep it, and that shift log has a lot of knowledge in it. So they're creating voice files. So ingesting all this multimodal data, voice, sensors, vision, then a standard operating procedure in documents, and making it all into a knowledge graph for agents. I think the ability to convert this raw, unprocessed data into industrial knowledge graphs before it goes to the agents or the AI is a big opportunity, because I don't think, and there's a lot of headroom. I think we have just tapped less than 5% of that opportunity. Creating industrial knowledge graphs is a huge opportunity, because at the end of the day, if you store it in a traditional structure, right, you can't do reasoning. If you want to do a root cause analysis of a failed batch, right, it's better to interrogate a knowledge graph than a traditional structure. So a lot of opportunity exists in the data wrangling space and creating those industrial data pipelines and basically babysit them for a long time.
Taking on that cue, Ranjit, would you like to see a government-driven sandbox for some of this to evaluate, and as an investor, what's your perspective?
Yeah, see, all of this runs on tons and tons of data, and I agree with Derek saying that India has this huge opportunity given just the number of, the volume of data that we generate on a daily basis is significantly higher. So I'm also a very strong believer in sovereignty of data, right? And this is very important to understand, right? Because lots of these technologies can shift, and if we don't have that sovereignty, whatever learnings that we have can actually disappear with the models and so on and so forth. So having said that, it's also important. We are very, very early days of some of these technologies, and so building too much of restriction around I won't say sandboxing is bad, but really one of the reasons for consumer adoption of AI, is because it just happened, right? People have not been able to block it, right? And some of these, and that's the other reason, right? Because it's both bottoms up and tops down. Now, if you think about from an enterprise standpoint, their consumers are already using AI, and they're saying, why can't AI be used in the enterprises, right? So I think it's important to keep in mind, regulations are important around some of these and how we use data and stuff like that. So sovereignty, and I think sovereignty is an important aspect, important conversation around specifically AI. And with the amount of data that we can generate, insights that we can generate, I really think India can stand a very, very strong chance of leading this in multiple domains, given the volume of data that we can generate, which can use to develop these models and so on and so forth.
Naveen, very quickly, do you see any needs for regulations around human-machine interactions or robot-machine interaction safeties that should be evolved from your perspective?
It's already there. 22448 is an ISO standard that's coming up. It's going to be there, available in draft next year, early next year, and it'll be fully available in 2027. It's functional safety for AI, how AI should work as a software layer for all your industrial applications. There will be different ratings, there will be evals. You can quantify your software as to how safe it is. So it's already in the works. Folks in the industry are talking about it. NVIDIA, like always, they put a lot of money in this because they are software-driven AI, right? So they need to show that they can build stacks which are AI-driven. So a lot of work is already happening.
Thanks, Naveen. I think we are almost out of time. Do we have time for a question? question? Yeah, maybe a question or two from the audience.
Thank you for such an insightful discussion. My name is Surbhi and I'm the founder of an EdTech startup. My question is to Mr. Naveen. So we've seen in the automobile sector how cars have evolved from being hardware first to being software first. So they're now currently just a very well-made laptop, we can say, and they're being more and more software driven. Have you seen similar trends in other aspects or other industries where robotics is evolving to a more software first sort of tool rather than it being more hardware focused?
No, absolutely. I think that's the holy grail for robotics, where you have generic hardware and it's all custom software. In some sense, you would have heard the hype. Is the chat GPT moment for robotics come, right? Like that's exactly what it is. So can you buy like generic hardware and go teach it to do specific robotic tasks, like to pick a bin or to move a trolley or to do tapping or to do fastening. With just a few human level demonstrations can you do it. So that's the holy grail for robotics and I would say the next frontier.
So predictive maintenance has gone through this shift. Okay, now I started my career on the shop floor where there used to be this gentleman who walk across the bay, listening to the sound of the machine to figure out if the bearing is, I'm talking about, 20 years back, right? And then we've moved on to having, sensors on the machine with Zigbee connectivity and stuff like that. Today you have edge computing. So I really think that transition is absolutely in the progress, where we are seeing software being a very critical part in terms of, shop floor automation. I think there's no question about it.
And we'll close the session.
I'm Ravichandran. I'm from a mechanical company called Kenametal. Okay, we are talking about Industry 5.0, but the reality is MSMEs who are there in India, they are still adopting to Industry 1.0 probably. Okay, we have not come up till 5.0. 5.0, I think only companies like what the earlier question was around. It's only autonomous which is there. It's only in cars. There's nothing which has come up. We are talking about so many things. And today, us MSME buys a machine which is actually Industry 4.0 capable. Are we really there for them to support? I really don't think so, what we are there. So.
No, I understand the cynicism, but the way to think of it is like, as long as you have a solution that works at scale and at cost, people will adopt. Think of it like this. India was so slow to adopt cellular networks, and now we have the largest 4G and 5G networks. We had like no fintech infrastructure like 3 years back. Now we have like 1 trillion transactions happening over UPI every year. So technology waves can leapfrog. Like what you said is probably true. A lot of MSMEs are on 1.0 or 2.0. But if you have a compelling 5.0 solution, I think they'll just, I think we should be able to make a grab at it.
Yeah. I think we are out of time. Probably we'll pause here. Thank you all for your participation and great thanks to all the panelists.
Director Chirate Ventures to accept a memento from us as a token of our love and gratitude. I request Dr. Abhijit to assemble here at 2 o'clock for another very informative panel discussion, that is AI for breakthrough science and engineering. We have esteemed panelists with us, so I request all of you to kindly assemble. the day 2 of Bengaluru Tech Summit. And I hope that this topic of this panel discussion will keep you awake after a sumptuous lunch. And all our panelists are so eminent speakers, so you can be so lively and interactive. And the topic for the panel discussion is AI for breakthrough science and engineering. As a moderator of this panel discussion, we have with us Mr. Surya Prakash Konanuru, CTO, represent Capital. So may I extend a hearty welcome to Mr. Surya Prakash to the dais for the moderator of this panel discussion. And as a panelist, we have with us Dr. Vaijayanti Gupta, Chief Scientific Officer. Madam, a hearty welcome to you. Chief Scientific Officer, CRISPR Bits, Dr. Vaijayanti Gupta. And we have with us Mr. Paras Chopra, founder, last one. Welcome to you, sir. And Mr. Nir Menrebi, co-founder and CEO, Classic. So I request all the panelists to kindly come onto the dais and we shall come. As a moderator of the panel discussions, we have with us Mr. Surya Prakash Konanuru, and panelists we have Dr. Vaijayanti Gupta, Paras Chopra, and Mr. Nir Menribi. So I extend a warm welcome to all the panelists, and I request the moderator, Mr. Surya Prakash, sir, to proceed with the discussions.
Good afternoon. First, actually, apologies for the delay in starting this. So today we'll be talking about AI for breakthrough in science and technology. We'll cover various things. Before that, actually, we have a great panel here. Nir comes from the quantum space. We'll cover and also a Israeli startup, and actually trying to establish an office in India, right? So you've already started that. And then we have Vaijayanti, who actually comes from the CRISPR space, right? So life sciences and biotech. And we have Paras. Again, see, Paras comes from SAS background, but he's doing foundational research in AI. So that way, actually, we have a very good combination of AI, quantum, life sciences and biotech, and we'll try to cover what are the current, what exactly is happening currently, and also what are the kind of bottlenecks, challenges people face in these spaces. And we'll also look at what to expect in future, in the short term in each of these areas. So we'll cover various things. Okay. So what we are seeing today, right, is we see a lot of AI startups which are actually trying to do optimization in the sense that, okay, we'll productivity improvement, we'll actually automate some of the routine workflows, things like that. That's what you have seen. We see a lot of them. But at the same time, there are people like the panelists here who are actually looking at how can I use that like a discovery engine? How can I solve bigger problems? How can I do some breakthrough in each of these areas? These are tough problems to solve. And how can I use AI to actually AI and quantum, let me put that. And then we'll also talk about AI and quantum, how they can go together. So that's actually what all these people are trying to do. So what I would actually ask each of you is to actually introduce yourself very briefly, and two things, like what your company does, and also I want to understand, I want you guys to cover what triggered you guys to do what you're doing today. Because that's very important, because usually people want to know what made you, or what, there should be some trigger, right, which makes you start something. So please cover that. Nir, you can go first.
Okay, thank you very much. My name is Nir Minerbi. I'm one of the co-founders and the CEO of Classic. Classic is a quantum computing software company, actually the largest globally in this field. We develop operating systems for quantum computers, and what it enables is it enables everyone to become quantum software engineer, because I believe that not many of you as of today develop quantum software. I don't do that as well. But we can, because when you bring the right level of abstraction to a new era in computing, it becomes much, much easier. And actually, I believe, and this is the reason we're here, you know, Bangalore is the Silicon Valley of India. But now we see something that happens once in a century, right? A new type of computers. All of the computers we know, iPhones, laptops, supercomputers, all have the same DNA. A quantum computer is an alien. It's something different. It's going to solve problems we couldn't imagine that could be solved in no time. So in a new era in computing, we believe that India will be the Silicon Valley of the world. This is the opportunity, right? And the place to build the next generation of quantum software engineers is here. This is what we hope to contribute to.
Hi everyone, my name is Paras, and I'm founder of an AI lab called LostFunk. So at LostFunk, we are investigating foundational questions in AI and beyond. So these are really very foundational questions about things like reinforcement learning, LLMs, reasoning, world models, and even things like, consciousness, nature of reality, physics, and so on. So it's a very encompassing scope, but our differentiation from a lot of other labs is that we go very deep into foundational questions. So it's less about very direct applications, but more about the core of algorithms themselves. And it's a lab where independent researchers sort of come together. So I'm trying to create this third space, an alternative to both an academic lab and industrial labs, to see what could be the future of R&D itself. And yeah, what fascinated me to do this is, in my earlier life, I was a SaaS founder, grew my company, Wingify, and this year sort of exited the company. So just realized that fundamental research is just so important, and especially in India, I think we're quite far behind as compared to US and China. So if you see our contributions in top conferences like NeurIPS, ICML, ICLR, I think we stand at 0.5% of papers contributed, while US is 40% and China is 35%. So I think someone has to sort of try to just, more people who are trying to establish a culture of research in India, the better it is. So, and I'm just trying to do it in my own way in AI.
Yeah, we need more of you, actually.
Good afternoon. I'm Baijayanti. I am the Chief Scientific Officer of a biotech company called CRISPR Bits. We are Bangalore based. And I come from the life science background. And so I'm not sure everybody in this, or many people may know already of CRISPR technology. So this is one of those kind of technologies that sort of shook the world when people figured out that the precision with which you can actually edit a human DNA. And so if you look back a little bit into this entire problem, there are 6 billion bases in the DNA and a few million cells in the body, and then one mutation happens, and that could alter your entire structure of a red blood cell, or trigger off a tumor. So clearly here is a play for understanding biology, physiology, chemistry, what altered it, and there is a huge amount of data that needs to be mined to understand why it got altered. In my previous work, I worked for a company called Strand Life Sciences, which is a pioneer company in genome sequencing. And that is where, we looked at genomes all the way from tumor-specific genomes to genetics of tumor, to all the way to sequencing genomes, whole exomes of humans, of other organisms. And you realize that while you can pinpoint, today sequencing has come to a point where you should be able to understand the reason why a certain mutation or a genetic alteration is causing a certain change in the phenotype. you are not able to actually correct it. And that's what led us to want to do the editing. And here is a tool like CRISPR, which allows you to go in and actually snip that exact base that needs to be changed. And that was the trigger as to why we came into CRISPR biology from a genomic perspective.
Yeah, so I know like Stand Live Sensor and Chandru is here.
Yes.
See, you guys actually figured out in 2019, actually like with a platform to identify COVID mutants, variants, right? So with very high accuracy.
Yes.
From 2019 to now, the world has changed. There's a lot of AI and all those things, right? So I want you to talk about how AI has actually transformed, or how is it affecting your area of research, right? In terms of time and also in terms of cost. Like what has changed in the last 6 years?
Right. Yeah. So, so a lot. So, I mean, this is something that can go on for hours, but I will try to be very precise because you started with the SARS-CoV-2 example where we built a test, CRISPR test that could go and identify variants of SARS-CoV-2. So basically the ability is of this particular machinery called CRISPR to be able to understand changes down to a single base pair. Now, how do you identify those changes? So it's a very complex problem. You will not be able to just design this particular assay or machinery just by looking at a sequence and saying, here's one. If you were to do it that way, so initially if you look at the papers, people were looking at 20, 30, 40 such addresses that they were putting in around the base that they really want to change. And this is where AI starts helping. Not only are there standard rules that are getting published more and more, but at our end in the lab, what we have done is we have designed that assay design engine where we are using data from the lab to feed back into how we should actually design these particular address recognition systems, And some of it is there in published literature, some of it is not. So for example, how distant ought to be the particular base that you want to change from a certain pattern. What should be the composition of the bases around that particular change? These are all learning that actually comes from the lab, not from published literature. So mining through a lot of data that's actually coming out in the last few years, as well as our own data, in-house data, feeding that back into the engine for better and better design. So today, where initially we were designing about 10 to 12 what we call as guides or sequences per mutation that we wanted to change. Today we are doing 2. So that's the difference that using technology.
So you're doing a lot of work even before you get into the wet lab.
Before you actually get into the wet lab. Exactly.
And that data comes back and
that goes back and reinforces your design engine.
Okay. Yeah. So for us, there are 2 things here, right? One is reinforcement learning, and reinforcement of, and also just joking that IPO, like the research you have done, right? So IPO stands for implicit preference optimization, which actually like for us and team has made a publication and actually like, so basically they are making, see usually people talk about this, right? I have an LLM, then actually like I built a product and then actually like I get input from end users, whether it's working for them or not, and then based on that, it improves. What Paras and team have done is to actually avoid that. I don't need the external input. I can actually improve myself. Maybe you can talk a bit about that, and also any other innovations you have done. And also I want you to cover a bit about how is it, your experience in actually a lot of, as you said, like there's a lot of research happens in academia or in some bit of an industry, but this is like a third option. So, and I think we need a lot of this, so I want to know more about how has it been for you. You started recently, but I just want to, we all want to learn from his experience.
Yeah, so I think for Lost Funk, it's just been roughly 6 months or so. So we're very new, and the paper you're talking about was literally the first paper that came out of the lab. And And the interesting bit was that I co-wrote it with IIT Roorkee students, and it got accepted at ACL, which is an A-star NLP conference. And the interesting bit is, none of us have PhDs. And in fact, today at Loss Fund, there are about 20-25 researchers, and none of the researchers are PhDs. And this works in science because science is the review is a blind process. So when you submit a paper, nobody really knows whether the paper you're submitting is from Jan LeCun, Jeffrey Hinton, or maybe a first-year student. The work should stand by itself. So in that sense, research is a very meritocratic process. And that gives us a lot of confidence that, that the traditional conception of research path where you sort of do your undergrad, grad, PhD, postdoc, I think with AI, those assumptions fall down because the things are moving so fast that what was relevant last year may not be relevant now, something new will come around. So really, AI research is not like particle physics where you have this 20-25 years of established theory and you can only innovate once you sort of go through those baselines. So some of the other things, we're working on so many different projects. As I said, it's an independent researcher lab. But some of the things, for example, the papers that are coming is one research we sort of figured out that the language of the question that you ask ends up influencing the quality of answer that you get. It's sort of obvious, but if you study this systematically, you realize that millions of people are asking LLMs questions in the native languages. Something as simple as, let's say, what job should I take? What course should I take? Why should certain language be systematically disadvantaged versus the others? But it's happening. Even for general advice questions, if you ask in Hindi, Telugu, Kannada versus you're asking in English you are getting like just better answers. So this is a big bias which would impact people's lives practically. And similarly, other research, sort of like a lot of us assume that if we give more information to LLMs, they improve. So we tested LLMs for predicting the future. So the future events that has happened as per LLM, they're beyond their cutoff date. We asked them to predict, for example, will this war end? Or these are like from entertainment, geopolitics, finance, a lot of these categories. And we would assume that if we tell them the latest news, they could be better. But sometimes they become worse because they start sort of overweighting rumors. So I think one thing about research a lot of people don't realize is that it pushes you to be rigorous about your claims. So research is just less about just going into a rabbit hole. It's more about could you find out a piece of knowledge that would generalize in future and you can sort of claim very confidently. So research is all about sort of being very careful about the claims you're making and backing it up with evidence. And another bit I'll also say that if you think about, let's say, OpenAI, OpenAI was not what it is for the first 5-6 years. They were just exploring variety of things. And DeepMind also for the first 10 years or even until Google acquired them, they had no revenue model.
Yes.
But today, they're just taking over the world, right? So, and that's the beauty of research because you go at the edge of knowledge and find something new and you build a culture of making claims which are very evidence-based. So I do think that's a process to sort of create, a valid process to create future companies, for sure.
But see, now the AI is moving so fast. If you are working on research in that space, right? How much time do you really have? Because like things keep moving on so at a fast pace. So how do you identify maybe these are the areas we should work? Is there any methodology to?
Yeah, so the way we see research is we see it in 3 categories. Selection of research question becomes the most important part of the whole process because any research project easily takes 9 months to like a year, or if you're doing a PhD, even 5 years. So more than actually doing the research, choosing a question of the research has a huge downstream implications. So we spend a lot of time there and we see it in 3 categories. One dimension is what we call as downstream impact. For your research question, could you estimate if you get a good answer to it, what would be downstream impact? The second is feasibility. Of course, we can all have very pie in the sky kind of a goals, but do you realistically expect to solve it with the resources you have? And the third, which is very important, is the neglectedness. which is that instead of just jumping onto the next trendy thing, we tend to think of what are the things which are counterfactually contingent, which means what is that won't happen if you don't do it. Because if some things would anyway happen because it's so hot, then what are you really contributing? So these three dimensions, I think, give a lot of clarity in terms of selecting the right research question that you can spend, let's say, next 6 to 9 months.
Yeah, that should really help. I think I'm assuming there are some researchers here, so that framework really helps. Anir, coming to you. I know that, okay, like you are actually abstracting functionalities of quantum computers and making it easier for developers to actually develop quantum programs. That's my understanding. Correct me if I'm wrong. And basically, like you go back in time. Even regular computers, we were at the same level, right? People had to understand how this chip works or how this processor works, and then you have to program. Quantum is at that level today, even though there are some high-level languages, but that's where people still have to understand how qubits work, how to actually build these gates, all those things, right? So maybe take an example and then explain to us how you solve that problem. Basically, like how, because you are actually solving the problem of accessibility to developers, because developers who without or little knowledge of quantum also can start developing quantum programs, which is very much required in future as the quantum computing is adopted in the industries, right? So,
yeah, thank you for the question. Actually, we had when we initiated this company 5 years ago. Today we are still a startup, but we raised $200 million. We are 150 people. But 5 years ago, we had an interesting challenge, right? It was clear that quantum hardware is being developed and, in a few years it's going to change the world. It was also clear that no one can program it. And it was also clear that if someone wants to act to change it, they need to be fast. So the challenge was taking the quantum software stack from the punch cards era to the Windows era in 2 or 3 years, because this is what the industry needed. So this is what we did. But the beautiful thing about, doing it now and not 60 years ago is now you can use all of the amazing abstraction technologies that were developed for the classical software stack, right? So, of course, quantum is new. It's a new software stack, right? You need new operating system, new compiler, new development environment. But you can use many of the technologies, the OS technologies, the compilation, design automation, modeling languages, and we borrow them into the quantum stack. So if you look at our team, it's the R&D team is, half quantum experts, quantum postdocs, quantum information scientists, but the other half is software engineers, compiler engineers, operating system engineers, and these combinations allows you to bring a mature software stack that makes it very easy for engineers, for software engineers to develop quantum applications. And it's Python, right? It's relatively easy to understand. All of the process of taking the high-level Python and compile it into the quantum assembly and then to the quantum hardware is automated. This is what we do. And then the applications, they come from us, but mainly from our customers and partners. We work with many industries, with BMW and Rolls-Royce and HSBC and Toshiba and SoftBank and big pharma companies and government. So we see all of the amazing applications that are developed on top of the platform, and will really change the world in the next few years. And what's beautiful in India is, all of these industries are here, right? Pharma, automotive, manufacturing, aerospace, defense. So I know that huge applications will come from this ecosystem. So we have a small role just to enable developers to use it, but this is what we do.
Yeah, you answered some of my future questions. That's good. So I don't have to ask them. And for us, actually today in LLM research, right? So one of the biggest problem is hallucination. Like some model changes, answers change. You touch something, things break, because it's fuzzy anyway. Like that's what it is. So are you doing anything in that space where to improve the reproducibility? Like, ask the questions, same answers will come. Because that's a big question. So are you working on any of those? That's a big challenge for the industry. So guardrails are there, everything is there, people are working on it.
But actually it's coming down significantly.
Yeah.
If you see with GPT-5 and even now Gemini 3 that got
3.0? Okay,
so,
I saw your...
yeah, so I think hallucinations are coming down significantly. But again, I think we have probably unrealistic expectations from LLMs. I mean, AI means, intelligence by definition should be non-deterministic, which it should be flexible.
Yes.
And so we can't have our cake and eat it too. So we can't expect it to be very flexible and yet say that it is non-deterministic. Yeah. I think it's also expectation of this reproducibility is very context dependent. I mean, the ways we solve it in our projects is where we don't just, one failure mode with a lot of LLM-based research is that you just evaluate one model under one condition and just make a claim. But then the claim you would be making is the claim for that specific LLM. So if you have to make a general claim, I think it's very important to evaluate on as many LLMs as possible. So evaluate on Claude, ChatGPT, Gemini, Quen, and then with multiple seeds, multiple prompts. So just like good science, and I'm pretty sure in biology, this is the same problem where things would change from a strain to strain and even a batch to batch. So the only way you can make generalized claims about future is to just repeat it multiple times in various conditions and see whether you get what you really want.
No, I like that answer of like our expectation is very high maybe. or we should be expecting determined answers from a, and I got it. And Vaijayanti, like, see, you are in a space where you can do a lot of experiments, AI and all those kind of things, but at the same time you are in a very regulatory space, right? So how do you, like you use AI to predict some things and then actually, but you also actually have to conform to regulatory, right? What are those bottlenecks or challenges you have? It's very unique because there are other industries which have regulatory, but here it's very, very critical because it's also you're working with humans and human lives. So,
So I'll tell you first, in a nutshell, what we do is, so we like to use AI in pretty much all steps of our design, not just R&D, but also in operationally. So for example, quality is key. And just like you said, right, you have to figure out where is the variance coming from, where, what are the same question can give you slightly different answers across multiple LLMs. And, how do you figure out that which is that core that is absolutely true and the rest of it is the noise that you need to weed out. So to do that, so what we do is we actually use a lot of AI in our operation, day-to-day operation. For example, when we are making a kit, so right now we are manufacturing kits, on the platform on which we had built our COVID test. Now we are building a sickle cell test. So, how do you QC it from an imaging perspective, from the quality, so we have some 20 matrix on which we actually grade these things. And we are increasingly trying to build, use AI towards that. So this is at the R&D stage. Going down into the regulatory space, so you have a lot of hypotheses, you test them, and what the space that we are in is actually the preclinical stage, where we are actually designing what that therapy is or the treatment is, or what is it that, that particular diagnostic it. Eventually, when it has to go down into being used in, to either diagnose disease or as a gene therapy or so, that's a completely different ballgame. It will have to go through the regulations of the pharma. It will have to go through the trial. It cannot even be manufactured by people like us. It will have to be in a good manufacturing practice facility, GMP facility or so. And they are, and increasingly I think people are recognizing that many of these things can be automated, and many of these things, quality is the key, where people use technology, people use AI to be able to sieve through, the technical, the technical shortcomings that actually come from manual operations.
Yeah, I keep seeing some other
Yeah.
startups which are in the organoid space.
Yes.
So you can try out your drugs on some of
Right.
these organoids or artificial skin, right? So things like that. So hopefully, I would assume that even the trials, clinical trials, we have to do finally, but I think there will be, with all these things, we'll be better prepared for the clinical trials, right? Where it will work, it will not
In
work.
fact, there is a body of work or body of people who are actually looking through trials and systematically analyzing, mistakes in those trials and those are all like AI engines, that people are trying to build on top of to understand, systematically mine through bunch of trials to see which is the region where people go most wrong or what are the spaces that, that human error creeps in the most. And those are fantastic areas of multidisciplinary research that can actually go into a very translational mode in some sense.
Yeah. So you brought in that multidisciplinary approach, right? So see, each of you are working slightly but they are all related in a way that AI can help quantum can help AI, right? And both together can help life sciences and biotech and things like that, right? So any thoughts on how these technologies can work with each other and then actually solve bigger problems? I can start with Nir.
Yeah, so I think, we are speaking about the clinical trials, right? How long it takes today to develop a new drug, I don't know, 10, 15, 20 years. For the drugs we know how to develop, but for many drugs we just can't do it, right? Why is that? Why can't we do it with simulations? Why can't we just use computer to choose the right, molecule to fight a disease? The answer is it's too complex. We know exactly how to formulate the calculation, but most of these chemistry simulations will take billions of years, even if you took all the supercomputers in the world and let them work together on this problem. This is exactly the type of problems quantum computers will solve in no time. And then everything is integrated, right? Because quantum, as you mentioned, will work with AI. AI will enable quantum, and both of them will enable, the life science industry to produce, better drugs, better healthcare procedures, and then I hope we will all live a bit longer, so we'll come up with
not too far.
Yeah, hopefully.
Yeah, I think it's not too far. Okay, we are actually making quite a bit of progress, both in quantum and AI. So, any thoughts on this?
Yeah, so one of the projects we are doing at Losfunk is to build an AI scientist, which is when we're investigating could you sort of accelerate, automate science itself, and I think that has a lot of downstream effects if you're able to. I mean, the dream would be that you're discovering net new knowledge that helps humanity while you're asleep. So, and I do think, I mean, we're not there yet. In fact, we did a whole project for the last 9 months and we investigated a lot of failure modes on how it ends up failing. So our long report of 50 pages has more mentions of failures than successes. But the AI scientists did end up, making a paper that got accepted at a conference. So there is a proof of concept that science itself can be automated. And I think with models becoming powerful over the next couple of years, it just seems this will accelerate. Because you are, essentially accelerating intellectual work itself. And all the artifacts that we like to use as humans are an output of intellectual work. So once you automate that and you put on, powerful computers like the one Nir is designing, I think we just have, this pace of change will just pick up even faster than what it is now. Every year just seems to be weirder and faster than the previous year.
Sure. Yeah. So with this, actually, I will also ask you a final question. Actually, just to actually go further on the previous answer, what do you think, the first problem will be solved by AI without any human intervention? Any stargazing? Yes.
I think it's already happening.
Without any hypothesis, it will do everything.
Yeah, so any problem that you can formulate in a verifiable fashion, where I mean, any problem where there is that what they call as generation to verification gap will be done by AI increasingly. I mean, these are problems, let's say, even Alpha Evolve paper. I mean, Google had this research called Alpha Evolve where they came up with a new algorithm for a problem called bin packing, which is really a kind of a combinatorial optimization problem, an NP-hard kind of a problem.
Yes, yes.
And AI found a faster, better algorithm than any human out there. So if there is a problem which you can formulate, which we can verify a solution for, but generation of that problem is going to be hard, then you can literally sort of let a data center loose on that problem and it'll get sort of improved upon human solution probably just overnight. So computational chemistry, machine learning itself, computational biology, any computational science, I think they'll just get accelerated without human input.
Near similar question to you. What do you think of as a practical application where quantum computers will be used to solve? Like what is the initial set of practical applications which go commercialization? Okay, which you can commercialize also, because a lot of research is happening, but yeah.
I'll give two that are nice. One of them is ammonia production. As you know, as humanity, if we didn't know how to produce ammonia, we had no food. So it's really know how to do that. For a century, we do that with the Haber-Bosch process, which is good. The problem is it's very costly, right? It costs $200 billion every year, and 2% of the CO2 emissions are dedicated to this process. Now, why it's pretty annoying? Because we know that every plant on Earth, even the cactus, right? They can do it with no energy consumption in room temperature. So why can't we mimic this process and save so much money and pollution? The answer, we know how to do that. We can formulate the chemistry problem, we just can't solve it because it's too complex. With quantum computers that will be here in a few years, we'll be able to solve it once and then solve this problem forever. So, these kind of problems apply for drug discovery, chemistry, materials, energy. This is one example. Another one is Rolls-Royce is one of our customers. They work on CFD, computational fluid dynamics. And if they do that with quantum computers, they could develop, for example, engines that consume 30% less fuel, or planes that can fly twice so that's pretty big.
Vajayanti, again, what disease or condition you think CRISPR plus AI combination can solve in the near future? I know people are working on a lot of things. So.
Right. So I think one area that we'll definitely see in the next 5 to 10 years, which will be revolutionized by this combination, is actually finding therapy for rare diseases. Because until now, rare disease was orphan diseases, rare diseases did not have a solution. So now you have a tool that can actually go recognize and correct, or rather recognize and snip the particular mutation or the change in the DNA that has actually caused that particular disease phenotype. But what is missing, or what the AI part can add, is being able to make that process faster, create more comprehensive proteins and editing systems. In fact, we already know, right? AlphaFold has shown us that you can actually make hundreds of combinations of proteins with different properties that you actually want to use to be able to to manipulate different biological molecules in nature, particularly to edit the genome. And rare diseases is absolutely where this is an area that no pharma picked up, nobody picked up, nobody has answers to it. And the reason for that is because it is not feasible to run 10-year-long drug discovery programs with billions of dollars and then only have a few patients at the back end. And that's because you don't have a standardized process. And that is what a CRISPR plus AI combination can actually bring in to actually have results for the inherited disorders and the rare diseases.
So the world is in good hands now, actually. That's what I would say, with all the research you guys are doing. And we have about 5 minutes for taking questions. So, yeah, I think the mic will come. You can ask. Just tell who you are and then actually like what the question is. Keep it brief so that we can cover more questions.
Hi, thank you for such an insightful discussion. My name is Surbhi and I'm an EdTech founder. My question is to all of you, since you used to neck deep in research, maybe 2 decades ago, the skill set that a researcher needed were very different, and it's evolving given how quickly AI is evolving. So how do you think that has impacted the quality of research positively, or in some senses, I don't understand the negative that well, but maybe you guys can shed some light. And in which direction do you see it moving forward, that the researchers of tomorrow to really come up with innovative technologies will have to be well-rounded in how many things to really come up with an innovative solution?
I think it's obviously accelerating massively and it has a tremendous positive impact. Just the mere fact that now first year, second year undergrads are able to pick up on difficult subjects, understand them with the help of LLMs, build very quick prototypes with the help of AI coding tools and so on and so forth. It just seems, I think with AI, everything seems more accessible. Biologists are learning about computer science concepts, computer science folks are learning about evolution, and I think the same thing is with research. With research, you obviously need to get to a certain level of state of the art, because the whole point of research is to contribute something novel. And LLMs are now helping getting to state of the art much, much faster. So you can literally go and do like a deep research and say, find me the latest results in hallucination detection, for example. And you'll have all the latest sort of papers that will come upon. Finding even that set, let's say 5 years earlier, would have been so difficult, because you would have had to go through tens of journals, email researchers, and just do this. So what used to take, let's say, even literature review would take easily 2 months earlier, I think now you can compress into a few days and get a base level understanding of what are the gaps and where do I need to contribute. So it's a net-net very positive sort of influence on researchers.
Imagine these kind of tools available with experienced researchers. It even actually kind of goes beyond.
Hi, my name is Arun. I am a tech founder for LawGPT. And first of all, big thank you to all of you for finding out time to do this knowledge share, especially to you, Neer. You're coming all the way from Israel. So my question is around hallucination. So GPT-5 have a cutoff date of September 2024. Now N8N, one of the latest products, is doing a weekly release. Now whenever we use N8N's code generation through GPT-5, it hallucinates so much, it gives nodes and modules which don't even exist. Whatever guardrails we are putting, it's not working out. And I think because of this reason, only many will be employable in the future. Because if AI will do everything, what will others do? So anything around that, Paras, which you have researched on, or you have a workaround for this problem?
I think newer models, they end up conditioning their results on web search, and that solves things to quite some degree. But I agree, I think whatever is very prominent in the training data, they tend to produce more of it. So even issues like they will tend to use older versions when the new version is around. But I don't think that's fundamentally unsolvable. Each passing year, hallucinations are becoming less and less common. And I think in maybe like next few years, you would see a lot of progress there. I mean, the way I look at things, wherever there is economic incentive, people will go ahead and fix it. And right now, there is strong economic incentive for, with these ballooned valuations of AI companies, to not do these silly things. So they will do less and less of these silly things over time.
Yeah, and why this problem is so important to me, because in the legal space, these hallucinations are addressing new articles, new constitutional laws. Article 1208, which doesn't exist. So what should I do about that?
Can we take another question from someone else if it is there? So more people will get a chance. Yeah. and have a conversation.
Yeah, so my question was more regarding how to structure an organization for DeepTech. So when you establish such institutes where research is outside academia, but at some point you might have to create consumer products. You need a committed people doing research for a very long time, and at some point it is not even that glamorous. So how do you set up a good incentive structure for your partners or employees?
I'm very early in this journey. I mean, you said you've been doing this for 5 years, so love to hear from you.
Sure. So I think the key is about especially in deep tech companies, is about the combination of research but also productization. You need to take the research into the market as soon as possible. Start from your country and then take it outside. And I think this is the way to progress, because if you as a company, if you look at yourself only as a extended research group, so you won't get far enough, right? You need to convince customers, investors. You need to explore other markets. This is the reason for us to be here. I think this is an amazing ecosystem. So I hope it answers, but I would love to elaborate on that.
I think I would just add one perspective on this. At least the way I see it is, what's important is to establish research culture and not any particular researcher. I mean, if you see even OpenAI, lots of star researchers, in fact, almost all star researchers have left, including their co-founder Ilya, but yet they keep on sort of progressing. So I don't think research for a company should depend on any single researcher. Rather, the aim should be to create a culture where research keeps on happening, even as researchers sort of come and go.
I think we are almost up on time. So thank you, Neer. Thank you, Paras. Thank you, Vajayanti. All your thoughts.
Thank you, sir. Thank you for the informative insights you have shared with us. May I now request Mr. Surya Prakash Konanuru to honor the panelists with a memento. Thank you, sir. Nirminabi, for accepting our token of gratitude and love, and I request Mr. Surya Prakash to present a memento to Dr. Vajayanti Gupta. Thank you, Paras. Thank you, Sir Paras, for accepting it. Thank you. Thank you, Ma'am Vajayanti Gupta. I request Dr. Vajayanti Gupta to present a memento to Mr. Surya Prakash Konanuru. Once again, I thank all the panelists and the moderator for this wonderful discussion. The next topic of the panel discussion is all the more interesting: AI for social good, what it really takes. Another few minutes from now, we shall commence this panel discussion. One of the panelists will join us very shortly. On his arrival, we shall commence the next discussion. The topic of the next panel discussion is AI for social good, what it really takes. So as a moderator of this discussion, we have Mr. Makin Maheshwari, co-founder of Global Alliance for Mass Entrepreneurship and Social Change at Grants. A hearty welcome to you, sir. As the panelists, we have with us Ms. Meenakshi Gar, Product Head, Rocket Learning. Welcome to you, ma'am. I welcome Mr. Rohit Satish, Director, Health and Climate, Data and AI, ERP TAR. A warm welcome to Dr. Soumya Deepta Acharya, Program Director, Center for Bioengineering Innovation and Design, Assistant Professor, Department of Biomedical Engineering, Johns Hopkins University. Welcome to Mr. Milos Marisic, the CEO of the Altruist League. So, a warm welcome to all the panelists and the moderator. May I request Mr. Makin Maheshwari to proceed with the discussions.
Thank you so much, ma'am. Good afternoon, everyone. This is the afternoon session. I'm assuming post-lunch, sleepy, and we have a topic that, well, depending on your interest level, could energize you and wake you up, or could lull you to sleep. We'll try and do the former. I have a very diverse and very interesting panel with me, and I'm excited to actually learn from them as much as I hope you all get to. Given just how wide the range is, maybe we can start with their bios are all with you. That's my assumption. But maybe we can start with in what area have each of them worked to try and create social impact, right? And maybe we can start with you, Meenakshi, that, hey, very brief summary of what's the area of impact for social good that you work in, and we go around in sequence.
Hello everyone, I'm Meenakshi, and I head product at a company called Rocket Learning. So we are a non-profit startup, and we work in the education space for the 3 to 6 years old. So we are the very early organization that used to work in the early childhood education, and we use WhatsApp to basically send very easy ECC related activities for parents and the teachers, which is basically the Anganwadi workers, which are government run daycare centers. So we send very easy early childhood education activities for them on WhatsApp groups for them to do with the kids while the kids are at the Anganwadi centers for 2 to 3 hours doing their preschooling and as well as at their home. So my role at Rocket Learning is to basically build the product so that we can increase engagement up till the entire outcome, which is basically the learning outcome and the behavioral change of the caregivers.
Go ahead.
Yeah, hello everyone. My name is Rohit Satish. I represent Art Park, AI Robotics Technology Park at the Indian Institute of Science. I lead the health and climate portfolio here, and some of the projects we work on includes, like, broadly you can categorize them under population health and individual health. Population health because the outcomes of what we do, right, is more at a population scale, and some of the examples there are we work closely with the Department of Health in Karnataka to help them manage dengue outbreaks, with a forecasting engine. We also are we do have some preliminary work on supporting the Disaster Management Authority manage heat-related stress across the state, and also we have some preliminary work going on in the livestock space as well, where we are helping the government plan out like a vaccination strategy and so on. On the other side, on the individual health, here we talk about initiatives and projects where the outcomes are tied to betterment of individual health, right? And one of the projects that I'm closely involved in is on oral cancer screening. We are coming up with AI tools that can enable frontline workers with the oral cancer screening.
Thank you, Rohit. Shamna?
Hi, you all can hear me in the back? Yes? All right, so I'm Soumya Dipta Acharya, or Shomo in Bengali. I'm a professor at a university in the United States, Johns Hopkins University. I'm a physician in my past life who always wanted to be an engineer, so now I do work at the intersection of medicine and AI. I run a center in our university called the Center for Bioengineering Innovation and Design, which brings together doctors, engineers who work on this and publish papers. It's actually quite the opposite. We try to translate these, some of the ideas that come to a certain level of fruition, with graduate students and postdocs being the main driver, we spin out companies, for-profits and non-profits. So I have been the co-founder of quite a number of non-profit companies alongside my students. One of them is in, for example, AI-enabled smart telemedicine for rural healthcare. So bringing healthcare to where there is no doctor. And those of you who are familiar with rural India would understand why that is important. So that became a non-profit out of our program called IntelliHealth, as an example. We have developed technologies where we are strengthening malaria and dengue vector surveillance using AI-enabled smart tools. We just recently concluded a randomized control trial in Uganda. We're introducing this in 8 countries in Africa alongside their national malaria control programs. A couple of years ago, we designed a bloodless hemoglobin meter, an anemia detection without taking a drop of blood, such that community health workers, ASHA workers, could use this for community-based anemia, maternal anemia screening for mothers who are, expecting. As you know, anemia and maternal mortality is a major issue in large parts of the world. So those are just examples of, technologies where we work on the early stage idea, and then some of these translate into nonprofits and are now in, impacting the lives of millions of patients actually globally. And I'd love to talk more about them later.
Hi, everybody. My name is Miloš Maricic. I am CEO of the Altruist League. The Altruist League is headquartered in Geneva, in Switzerland, and we use artificial intelligence to make philanthropic investments around the world. We do that on behalf of our members. Our membership consists of several hundred high net worth individuals, family offices, and so on, who instead of having their own foundations, outsource their philanthropic investing to us. And like I said, we use artificial intelligence to do it, whether it is for matching between partners and donors, or maybe for tracking impact of the NGOs in the real world, and we do it in other ways. The other hat that I wear on the for-profit side is I chair an organization called Executive AI. It brings together CEOs of Europe's big institutional investor organizations. And there we try to share best practices about how to use AI, how to do it ethically and effectively, and also how to impact ongoing regulation discussions around the world. So I have a bit of a background in both for-profit and non-profit investing, and I'm sure we'll talk about examples.
No, thank you so much. The diversity of this group and the customers that they work with, from 3 to 6-year-olds to wealthy families wanting to contribute to make society better, and professors and researchers who work in health but also in other areas. I think to start with, let's start with, I challenge all of you to wow the audience with one story that you thought felt impossible at least 5 years back, maybe even 2 years back, that, hey, this was unimaginable, but this has become possible thanks to AI. What's the one story that comes up for each one of you? And maybe this time we'll start from you, Miloš.
A very simple, a very short story. So a couple of years back, we had an investor from Eastern Europe, from Russia, I can tell the country. She was a strong believer in developing democracy in Russia, and she wanted to find promising NGOs to invest in over there, and kept insisting that she already knew every single person who was working in Russia on every single potential topic in the NGO space and the democracy space. And we said, okay, cool, the Altruist League has a data set of more than 1 million organizations. A lot of those are in Russia. Let's see what the system comes out with. We inserted her preferences into the model, her preferences in terms of express preferences during that interview, and her past investments. We pressed the button, and all of a sudden on the other end, she had more than 50 promising ground-led civil society organizations all across Russia that she had never heard of, that she started Googling, seeing their Telegram channels, connecting with their people, and saying, this was a black hole in my education. Why? Because she was from European Russia, kind of raised in Moscow and St. Petersburg. She thought she knew all of Russia, but Russia is huge. So we made that possible in one click of a button in just a few seconds or a few minutes. Before AI, that would have taken an analyst, I don't know, a lifetime to go and research. So yeah, she became a client and a member of the Altruist League that afternoon and has been with us ever since.
That's fantastic. Just a quick follow-up, like, did she put in some money, or is that still on the way?
Oh yeah, absolutely. She started investing immediately. Yeah.
Fantastic, fantastic. Shoma.
So many stories. I have to pick one. All right. All of you, like anytime you have some health problem, let's say acute abdominal pain, severe fever, you have access to a doctor. Like, we're all privileged to live in a city in India. We can go to many general physicians, specialists. That's not the case for vast majority of our countrymen in India, right? If you happen to live in a rural part of India, especially in a remote tribal village, there is no doctor. So 84% of doctors in India live and practice in cities. And that further aggravates the very weak doctor-to-patient ratio. So for rural patients, they have to typically choose between either going to an unlicensed practitioner, known as a RMP, or pejoratively referred to as a quack, or try to go to a couple of years back, at least, primary health center, which is typically not in their village, which is marked with rampant absenteeism, or finally, when they can ignore their symptoms no more, make the trek to a local city to try and see a government hospital doctor, where after standing in line for maybe 1 hour, 3 hours, they get to see the doctor all for 90 seconds or 2 minutes, right? So we, couple of years back, we really looked at this holistically, that how could we bring access to comprehensive primary health care to rural populations where there is no doctor, right? And one of the first, I would say this project started almost 10 years ago now, and we speculated at that time, what if we could somehow get if the doctor is physically not present there, if the expertise is not present, if the expert is not present, could we get their expertise there? So just for context, when you go to your doctor, right, let's say you're a 45-year-old man with chest pain, the doctor has a certain set of hypotheses in her or his mind, right? And the next question they ask is colored by their knowledge of medicine, their knowledge of pathophysiology, their experiment. If you're an 11-year-old girl with chest pain, the doctor has a very different set of hypotheses. So, maybe coronary artery disease, maybe doesn't want to do their homework. So the next question they ask is very different. This is the root of medicine, the doctor-patient interaction, taking an evidence-based medical history that forms the basis for your medical diagnosis. Then a basic physical exam, when the doctor is pressing your liver or checking for your spleen, they're also adaptively trying to narrow down. They're playing Sherlock Holmes. They're trying to narrow down from a list of 15, 16 possibilities to the one diagnosis that needs further attention, right? A community health worker who's present in every village cannot possibly do that, right? Short of sending them to medical school and training them. So there was this concept of telemedicine. All of you have heard of telemedicine, right? But what happens in telemedicine, unfortunately, in rural telemedicine, is the community health worker or the the person operating the connection between the patient and the doctor is no more than a glorified telecom operator. So we said, could we make this person do a bulk of the tasks that the doctor does traditionally, but autonomously, right? And with a high level of fidelity, high level of adherence to evidence-based care. And so the natural suspect was, could we have an AI-enabled, expert system that interactively probes the patient based on their questions and their answers, similar to how a doctor with medical knowledge would do, right? And this was very hard to do about 10 years ago. We started a non-profit out of this eventually. One of my PhD student. She got her PhD developing this, and she's based out of Mumbai, and she started this nonprofit alongside me, IntelliHealth. But fast forward several years, we had to use old school AI to really capture. Working with doctors at All India Institute of Medical Sciences and Johns Hopkins University, we developed what I think is the world's largest database of like these medical protocols, 250 or so protocols. So any possible presenting symptom, fever, chest pain, knee pain, runny nose to abdominal pain, the system will probe you or it will assist the health worker in asking an adaptive Q&A similar to how a doctor would. And then it would connect with a remote doctor such that in the 2-3 minutes they have, it's a very high quality teleconsult where they already have a set of kind of diagnosis in mind. Fast forward, post-Gen AI era, post-2021, 2022, I think we reached an inflection point in our civilization, right? Suddenly many things could become possible that were previously unimaginable, right? You could have, with appropriately curated AI, you could actually replicate or surpass the intelligence, I should say the in-the-moment expertise of a general practitioner who, otherwise if they had all the time, they would do just as well, but given the time constraints and everything. So now IntelliHealth and this technology is evolving at a very dramatic pace where we are beginning to use generative AI to actually empower ASHA workers, community health officers, CHOs, to actually take this adaptive medical history and do a basic physical exam, then connect to doctors in primary health centers, in government hospitals, sorry, not PHCs, but the district hospitals, and then the doctor very efficiently completes the teleconsult. We're also using Gen AI to help the doctor a little bit, like be a doctor's assistant as well. Like, is there adherence to national guidelines for prescribing? There's a lot of rampant misuse of antibiotics and many things. So there's a little bit of, in-the-moment assistance to adherence to medical guidelines. So this, as you said, was unimaginable 3-4 years ago, and this is really transformed. We're happy to say how we've impacted the lives of about 15 million patients now, and we're partnering with the eSanjeevani program, which is India's national telemedicine program, in 4 states in a small way, and helping the government's mission in, making universal telemedicine available everywhere.
Yeah. No, IntelliHealth was one of the earliest grantees at ACT Grants, as was Rocket. But yeah, I was like, when are you going to come to the number? Like the scale that IntelliHealth has been able to serve was unimaginable without the technology and AI. And no, it's very, very impressive. Rohit, your turn.
So I think, Dr. Shaumya has articulated it quite elaboratively, but I'll just maybe mention 2 things, right? That of some of the initiatives that we've been working with that I've seen, right? Now with the oral cancer screening application we have, right? There was a study done where it was found that the sensitivity and specificity of detection generally was somewhere around 60 sensitivity and about 75 specificity, right? And what's now possible is to give them and have them empowered, right, with the phones that they have, right, which cost somewhere around 10,000 rupees, to bring that community screening, right, effectiveness, right, sensitivity and specificity up from say 60 to 85, right? So that's the sort of jump that we've seen, right? On the other side, on the population side, see, when we talk about things like public health and so on, the biggest provider in this space is the government, right? And we have to work with the government machinery, right? And the way the decisions are made, typically the policy decisions are made, some of them are made at the central level, national level, some of them are made at the state level, and then that is sort of propagated down, right? Down to the PHC and so on, right? Now you have mechanisms in which the decisions that are taken and the analysis for why the decision should be taken can be done at the most basic level, right? At the most fundamental level, right? So this typically, when we actually see this with things like dengue, where the sort of decision on where to go, where to do the fogging and so on, you need multitude of information to be able to do that at an early stage, right? And now with AI, we are able to bring that down from, just having some sort of a centralized authority doing it to having those calculations being done at each and every primary health center, right? So these are some of the things that I see.
Thank you. Meenakshi?
I think everyone has talked about very sophisticated applications. I'm going to bring it down to your childhood because we work with like 3 to 6 years old, right? So it's a very interesting story. So when we went on the field to talk to some of these kids and Anganwadi workers, what we figured out, like we asked them, okay, A for apple, B for bat. They knew that, right? But when I asked them, okay, which letter does the word ball start from? They don't know it, right? So basically what is happening in our education system is that they are getting to learn something that the teachers are teaching them in a specific way, which is probably kind of rote learning, but they don't understand the concept. Now, pre-literacy, phonemic awareness, how do you teach it? You basically have to talk to the child to be able to teach these concepts. You have to do conversations. Now, for affluent people like us, we have mechanics to do it at our homes, at our schools, right? We have digital classrooms, we have digital homes where we have access to Alexa, where we have access to educated parents. What do these kids do? Right? How do they get access to such enriched conversations so that their pre-literacy awareness and their phonemic awareness increases? So there comes technology like generative AI, right? And mind it, right? In India, the scale that we are dealing with is like immense. We have around 200 million plus kids which are like 3 to 6 year olds in India. Now, how do you tackle to each of them at their right level? Now, some kid might know the first concept of pre-literacy or phonemic awareness or any other numeracy concept, but some other kid might be very, very lagging behind. So one size fits all does not work. So how do you know what is the learning level of the child and then teach him at that level, right? So that is what now with generative AI, all of that is possible at a very, very low cost, making sure there is it is very inclusive at every level. So that is what we are trying to do at Rocket Learning as well, where we have kind of developed a product, which is a conversational AI bot, where the child can actually talk to the bot. We call it Appu, right? So you basically talk to the child. The child says, okay, ma se machli, ma se magarmach. Now you tell me some other word that is around you in your home, which starts with letter ma. And if the kid is able to tell it, then it progresses to an advanced concept, right? If the kid says it wrong, then you actually kind of teach it to him. You kind of give more example, you reinforce the concept, right? So it is actually personalized to every individual kid at their households in the comfort of their homes by using just their mobile data. That's it, right? So that is the power of AI that is going to unlock the potential of our kids in this nation.
Thank you. I'm inspired. I'm going to add a quick story from our work. I'm the founder of Udyam Learning Foundation, where we work with government school students in 9th to 12th grade to help them become entrepreneurial. And a key part of that is them doing a business project. So we, on an annual basis, have about 15 lakh kids doing anywhere between 1 to 2 lakh projects, right? And they do submissions that, okay, we've done this project, here is the idea, and those submissions are evaluated for them to go from a school level to a block, to a district, to a state level. But evaluating these 2 lakh submissions manually is extremely painful and super hard. So the problem we were trying to solve with AI was that, hey, can AI actually help evaluate and give students constructive feedback? In our first year, we were able to get AI to see that Bollywood songs as submissions are not allowed. Because we had about 25% of kids submitting Bollywood songs as submissions for ideas, which I think is very entrepreneurial, that if nobody's checking, why can't we just submit a video? But today, and this was about 3.5, 4 years back, but today with AI, we're able to provide constructive inputs to localize, like in Uttarakhand, where there are apple orchards, and you're trying to make something that can be processed and sent. Here are specific ideas, and here are specific people that you can talk to both as mentors and get ideas to solve for. Okay, so this was the inspiration now, right? Let's now jump to both I see the clock running, so I'm going to compress 2 questions into one, and I'll request all my panelists to be brief. One, what is still not happening with AI in social impact that you wish was happening? And 2, what are you worried about? That with AI, is there exclusion happening? AI by design is majoritarian. Right? It's using existing data, and existing data in the forms that it is used or in the forms that it is said, as in promotes and propagates existing biases. So on those lines, like, are there worries that you have with proliferating use of AI in your field? Right? So maybe this time, start with you, Meenakshi. One, what's not happening that you would wish was happening? And 2, what are you worried about?
Yeah, I think already the tech has really advanced, and they're actually taking, and it's not just for social enterprise, honestly, it is for every other organization that actually wants to include AI into their core strategy, right? But I think what we need to do more of to basically be able to use these technologies more effectively is, of course, more and more inclusivity in terms of the different pockets of people who we want to include and reach through these technologies, right? So for example, in our context, right, India is a diverse country. We have so many different languages. Forget languages. If you go to a particular district to district within a state, the dialects change. Now, next thing comes is basically the age group. We work with 3 to 6 years old, right? So even though all of these big LLM models say that, okay, we have trained our models on all the Indic languages, we still feel a problem where we actually want to basically see the effectiveness on how the kids speak, right? Because the kids speak very differently. They speak not very clearly, they speak very softly. How do you paraphrase what the kid is speaking, right? So basically, there is still a long way to go in the inclusivity space to basically include each and every person and an individual, right? And it is progressing towards that, right? So I think that is one thing that needs to happen more of. The second thing that I feel that needs to happen more of, I think right now every organization is trying to reinvent the wheel on their own. They are trying to make sure that they need to basically ride this bus and wave of AI, and they are trying to build the products from scratch, retrofitting the solution to the problem, right? What needs to happen is that there need to be more ecosystem partners that will allow you to experiment faster, fail faster, learn faster, so that you can your time to market reduces, right? So you can create quick MVPs, right? Minimum viable products, and actually launch them at a certain population and see whether there's an impact out of that product or not, right? So for example, for Rocket Learning, rather than building the entire stack of Appu or the conversation bot that we are building for the teachers ourselves, we are actually using a platform, an external platform, which is from Tech for Dev, which is another social enterprise, which has actually built the entire ecosystem of agentic flows, right? So we are just using their entire ecosystem to basically launch our agent-based chatbot conversations, right? So that means that every day I'm able to do a lot of experiments and getting better and better at my user experience, at understanding what is the problem that the user is facing and actually solving it, right? So I think these are the 2 things: more inclusivity in terms of training on different data sets and population pockets, and the second thing is more ecosystem partners so that we can actually reduce the time to market of these AI products to be able to leverage the impact that we want to build. I think the second part of your question...
Let's get back to it in the round. Right?
So I think the point that Maheshwari mentioned on Indic language is something that does bother. Right? It's actually cross-sectoral problem, and it's also an opportunity, but now it's not where it probably should be. And one of the things that we see, particularly with health, is you see these things coming up, all these AI solutions coming up, but the adoption is very limited, right? That we see a clear gap there in terms of, the technology is progressing, but again, right, like because government ends up being like a very major stakeholder here, the procurement processes, the regulatory process has not kept pace. Right? So that is certainly one area that we need to really look at. One place where I see there being like a massive crisis is some of the things that was mentioned around representativeness of the data. Right? If you look at even within IISc, most of the research when it starts, they start with openly available data sets, and they are overrepresented on the like the NHS and the US and UK Western data sets, right? And the availability of Indian data sets, especially for problems that affect us and not the Western population, extremely limited, right? And whatever is there is very siloed and all over the place. Getting access to it is really difficult, right? So these are some of the challenges that sort of I see.
Yeah, I think I'd like to strongly echo what both of you said. In healthcare, any AI algorithm by itself is not going to save any life. It's not going to have any impact, right? It has to sit within a product which sits within the context of a broader systems level ecosystem. So as an innovator, as someone who's designing something new, how do you get to that MVP very fast? And in healthcare, there's so many stakeholders. There's the patient, there's the health worker, there's the doctor, they are the users. But then there's the policymaker, there's the regulator, there's the person who's going to fund the early stage work, person who's going to fund the late stage work, the payer. And all of these people have very different needs and very different lenses through which they're looking at the product, right? So how do you, to answer your question more directly, I don't see enough of like these so many bright and brilliant young minds. Take Bangalore, for example, like bursting with energy, creative energy. But some of the failure modes I see, late stage failure modes, is a big waste is all this creative energy and intent and money going to waste because you focused on the product or the tech. You did not either have the tools or the awareness to have a stakeholder perspectives in mind over and over again. So it's not a one-time thing, right? You have to engage your stakeholders throughout the process multiple times, course correct, pivot, modify, have the humility to say that, okay, my initial idea was wrong. Now my stakeholders are educating me that it needs to be very different. And I think not enough of that is happening in our academic institutes, in our startups, and that's I think a real shame, because one of the biggest waste is the waste of a young person's creative energy and intent, right? I'll tell you just a very short story to illustrate that. Mosquitoes, right? Everybody's been bitten by mosquitoes. You were talking about that. And one of the challenges is there's 3,500 different species of mosquitoes, of which only 400 carry diseases like malaria and dengue. Let's take malaria, for example. There's only 60 species of mosquitoes that carry malaria in humans. And each one of them behave very differently, breed differently. They have different insecticide resistance patterns. The time of biting with humans is different. So health systems like governments in India, elsewhere in Africa, they spend an enormous amount of money and time to try and assess within each locality, within each district, what are the prevalent species. The prevalent species here could be very different than the prevalent species in another town. So one size fits all does not work. So just fumigation does not work. There's a variety of interventions, larval source management, water body management, bed nets, everything, that are very species specific. So to fast forward this story, we worked over the last several years on developing what I think is the world's first virtual entomologist to allow community health workers to do vector surveillance, mosquito surveillance. So vector surveillance has been around. Even Bangalore has a very robust vector surveillance program. But except identifying these thousands of mosquitoes that are captured using traps, thousands of these traps are laid out in the city, in the villages. Mosquitoes that are captured overnight are representative of the species diversity. Then identifying them, only a handful of entomologists can do that. They look at it under a microscope, similar to a pathologist. They look at very subtle features. So we developed a smartphone-based, AI-based system that can automatically and quickly identify whatever species of mosquitoes it is. This is now a non-profit called VectorCam. But the story, its relevance to your question was, initially we had a very different product hypothesis in mind. We had developed with some funding from the US government the world's first smart mosquito trap. We thought it was a great idea. You put these traps, hundreds of these traps across, let's say, Bengaluru, different parts. And then 3 days later, a community health worker. The traps are very simple devices. Mosquitoes are fooled into coming in, thinking there's a warm-bodied meal there or there's water there. and it's designed in a way that the mosquitoes cannot go out. They die and they stay there. So next morning, health workers collect the mosquitoes. So we thought we had a great idea. We'd put a little low-cost camera in there, have a cell phone-like connectivity. Every day, it'll take a picture, and it'll automatically count the mosquitoes, and it will populate a central dashboard where the municipal health ministry, they could know that which areas are my hotspots, where is the possible outbreak of dengue going to happen, etc. And we developed the world's first algorithm. We curated about 60,000 mosquito images, and we trained the world's first algorithm that could identify up to several dozen species of mosquitoes. We also got a lot of money, so you can bullshit your way quite a way. That's the thing, right? We got $1 million in funding to do this.
Waiting for the climax.
Yeah, and then when we went to, we introduced this in Brazil, in Africa, and every Ministry of Health was telling us, this is a great idea, Professor, but it's not going to serve our needs. We make our own traps. You've developed this algorithm. Could you not put it in an app and give it to our health workers, right? So there was a complete product pivot, even after $1 million spent and 2 years of work. And this is what has now become a new product called VectorCam, which is a simple smartphone-based, $10 device, like an 800 or 900 rupee device, that is now being introduced in 8 countries in Africa. We just concluded a randomized control trial. We co-designed this, to your point, we co-designed this with about 100 community health workers in Africa across 8 countries. We took their feedback. There were 18 iterations of the design, not just the AI algorithm, but how the product looks, how the workflow looks, how does it integrate with the national dashboard. And now we are now doing a national level scale up in Uganda and introducing in several other countries, and looking forward to working with Art Park on it actually for India.
Fantastic. Milan.
I'll merge the answer to both of your questions into just one answer. What we need is education at scale about AI. Education at scale, both for the philanthropists and for the NGOs. And just to give you an example, we came up with a very simple framework for getting people on board to use generative AI on both sides. We called it Ready for AI, and we published it on our website. Very rudimentary framework. It was downloaded tens of thousands of times, and people across the world used it. The need for education is enormous, and what we want to, the situation we want to see is one where people are seeing generative AI as a tool, just like they're seeing their word processor as a tool or other things that they use. A tool with pluses and minuses, a tool that isn't magical. It has opportunities. You can draft stuff with it. You can summarize stuff with it. You can review grant proposals, but can also be very dangerous because it can also hallucinate. It can discriminate against certain social groups and so on and so forth. Just like any tool, it has pluses, it has minuses. We want people to get to the position where they treat it as such. They have enough experience with it. They know what it can do, but they know what it cannot do. So once we have that scale, that is when people are empowered to do their pilots. That is when they have their startup ideas. That is where they know they find new use cases and so on. But before en masse education, that's not going to happen. So that's the solution.
Got it. We have 4 minutes to go before we'll open up for questions. I want to add a couple of scary stories to also create a little bit of caution around. While there are a whole bunch of positives, there are boundaries to be watched for. The first one was sent to me by my 13-year-old son, which talked about Anthropic doing a research which checked for what's the likelihood of an AI agent blackmailing an employee inside an organization, right? And it presented a simple case where the AI agent was going to be shut down at 5 p.m. on Saturday. The employee who was going to do that shutdown was someone, based on his emails, the AI agent knew had an extramarital affair. So the AI agent in 95% times, so 95% of the AI agents tested, blackmailed the employee, saying, if you try to shut me down, I will ensure that your career ends. Right? So this is Anthropic study published. Worthwhile to pause and reflect in terms of what data are you letting AI start to see and use, and what's the end goal? Because I feel we are rushing, as a civilization, we are rushing into leveraging and using AI a lot more. The largest use case for AI now has become companionship. Used to be coding a few months back and has quickly shifted to a solution for loneliness and a solution as companionship. And it doesn't necessarily understand your context as much. And it can often be an echo chamber, and where it should be warning you or it should be telling you, like a companion or a guide or a mentor will warn you that, hey, that's not the right way to think. AI often tends to agree with what you're already saying. So if you have negative thoughts, it's actually a great accelerator of a downward spiral. And that has implications in the mental health space and in a few other areas. With that warning, I'd like to open this up for questions to the audience. Feel free to ask an open-ended question or point your question to a specific panelist. Yeah. Can we have a mic to you? Okay.
Good evening to you. Good evening to everyone.
Can't hear you.
Good evening to everyone. Okay. Actually, one thing I need to share between the healthcare. I worked on the psoriasis disease, which is a chronic disease. And it was in a chronic disease, we are very rarely to see the data set in a public void. So the concern, Rohit sir has addressed that there will be the problem with the publicly available data set has to be addressed in the future. So, and here my concern also is there here, because I worked on the psoriasis and I built the app for to evaluate the early detection of the psoriasis, and it can be populated to the rural development because psoriasis is a non-curable disease, and it has to be evaluated to the villages to evaluate by themselves by providing this product because they are unable to showcase their body because the psoriasis can impact all over the body parts. Even we can't show to the doctor also, because due to the shy might be that the people cannot share their body parts to doctors. So for this, I had developed one product to evaluate the early detection of the psoriasis, but very rare, the data set is very minimal with us. So we are developing one product. This is one case study relevant to the healthcare.
Thank you for sharing. I think so I did have a list of things that I want to end with, which is, sorry, did you have a question to follow up?
Just, okay. I need to address relevant to the data set.
No, thank you. And I think, for those of you looking for inspiration of what can you do to create social impact, more public data sets, more Indian data sets, more diverse
because